joining us today, December 13th. We are broadcasting live from ESA's Space Technology Center, ESTEC, here in Noordwijk in the Netherlands. And we welcome you on behalf of the European Space Agency, ESA, and the European Organization for the Exploitation of Meteorological Satellites, EUMETSAT. Tonight, we are following the launch of the first Meteosat Third Generation satellite. Now, whether you are with us on social media, watching on ESA Web TV, or you're here in the room, we are very happy to have you with us. My name is Kelsey Brennan-Wessels. I'm joined by Chiara Monter. Together, we will guide you through the next hour and talk with a number of experts who will be sharing many details surrounding the Meteosat Third Generation mission.
A warm welcome also from me, ladies and gentlemen, to this very exciting day where weather forecasting is about to rise to the next level. We would also like to welcome all our media representatives. So if you're talking about our event today on Twitter, LinkedIn, Facebook, Instagram, or any other platform, please do use our hashtag MTG-I1. And you'll learn in a minute why the I.
Now, we are about 100 minutes prior to liftoff. Right now, the MTG satellite is on board an Ariane 5 rocket, and that is poised on the launch pad at Europe Spaceport in French Guiana. Now, preparations are going well, so I think we can begin.
And let's kick off our program with these two gentlemen here. So we have ESA's head of the Earth Observations Project Department, Tony Tolker-Nielsen, and with him, Stijn van der Missen, the Deputy Head of Establishment here at ESTEC in Noordwijk. Stijn, thank you so much for having us host this MTG launch event here today. Why are we hosting this launch in the Netherlands? Is it because of the lovely Dutch weather?
If you like... Hello? Yes. If you like horizontal rain, yes, of course. This is absolutely true. But thank you for hosting this event over here in ESTEC. ESTEC is the European Space Research and Technology Center. It is what we sometimes call as well the technical heart of the European Space Agency. The place as well where space and technology shake hands, projects and technology shake hands on this side. And also the place where the project team of MTG is mainly based. So in this respect, we're very honored to have this special event over here, and we are looking forward to a successful launch today. Thank you.
Thank you very much. Stijn from ESA.
And over to Tony Tolker-Nielsen. Tony, ESA develops a multitude of satellites that are constantly looking down on our planet. How does MTG fit into this family tree?
Okay, so there are three families of Earth observation projects. There's our own Future EO envelope program. There's the Copernicus program that we are doing in partnership with the European Union. And we have the meteorological program that we are doing in partnership with EUMETSAT. So the Future EO program is the fundament of everything. It's a science-driven program where we implement innovative, world-leading missions in terms of science and technology. We call them Earth Explorers, and these Earth Explorers often later becomes operational missions. With Copernicus, for example, Cryosat has become Crystal in Copernicus, and Aeolus is now becoming Aeolus 2 as an operational mission with EUMETSAT, and there are many other examples on this slide you see behind me here. So Copernicus today is the gold standard in operational Earth observation, and we are now reinforcing Copernicus or expanding Copernicus with 6 new missions, and so we are reinforcing the European leadership in operational Earth observation, addressing crucial societal needs. When it comes to EUMETSAT, we are co-funding and implementing the space segment of the EUMETSAT missions. MTG is one example of this, together with METOP Second Generation, and soon to come Aeolus 2, and also the Arctic Weather Satellite Constellation. Tonight, we had the launch of MTG, the first MTG satellite out of a series of 6. You'll hear much more about MTG-I1 and also the MTG program. So I wish you an exciting event. It's a very important milestone for the MTG program. So go Ariane 5 and go MTG.
Thank you, Tony from ESA. Now, before we go into the details, let's get a quick impression of what the MTG mission is all about. Now I'd like to welcome ESA's MTG Satellite Systems and Operations Manager, Peter van den Brambesse. Thank you for being with us, Peter, to explain more. I don't think you need an introduction with this crowd. Thank you for being with us, Peter, to explain more about MTG. Now, the satellite is an impressive piece of machinery, but what is the reason for making it?
It's a satellite for weather prediction. Everybody would like to know the weather for the coming days, to make plans, to know what to wear. But not only that, we want to know if a severe weather is coming, like a big storm. We would like to be informed in advance, to take precautions. That could save lives. But not just for you and me. There's a €1 billion industry that depends on good weather forecasts, like transportation. So also for them, it's very important. And satellites are an important element for weather forecasts. They provide the data that is used by the models for the weather predictions. And ESA launched the first weather satellite in 1977 to geostationary orbit. So we now have already 45 years of continuous service of weather data for Europe.
That's great. And what is ESA's role in the MTG mission?
ESA's main role is the definition of the requirements for the system and the instruments, but also the definition of the quality requirements that are applicable to the industrial contracts. And we define the system requirements from the user requirements that we get from EUMETSAT. And then we try to define system requirements that are giving the maximum for the users, but at the same time staying on the good side of technological feasibility. And then industry designs and manufactures the satellites. And ESA places the contract and then follows up the development through progress meetings, reviews, and sometimes when we discover a requirement is too difficult to achieve, then we look together with industry for solutions.
Okay. Now, building a satellite is already pretty difficult, and then building a whole new satellite, well, that's even more difficult. What are some of the key figures of MTG?
The model you see here is a model of MTG-I, and it's a scale 1:4. So the real satellite is 11 meters wide and 6 meters high when the solar arrays are deployed, because to launch we have to fold the solar arrays, of course. The mass at the launch is 3.8 tons, but by the time we arrive in geostationary orbit, it will be much less, because we need a lot of the mass that's propellant to get to the right orbit. And MTG-I one is just the first of 6 satellites. So we have 4 imagers, like MTG-I, and then we also have 2 sounders. And the imagers, they contain more classical cameras, so they take images of what they see, the top of the atmosphere. We have the FCI instrument, that does it in different spectral channels, and we have the LI, the lightning imager, that does it for specific frequencies, for lightning. And then we also have 2 sounders, and they are different instruments. They take a kind of 3D image of the atmosphere. We have one, the IRS, in the infrared, and then we have the Sentinel-4 instrument that does the same in the UVN and in the visible and near-infrared.
Okay, well, in a little bit, we'll take a deeper look at the instruments that are on MTG-I. For now, Peter, thank you. I'm going to ask you to stay up here with me on the stage for a moment while we check in with your colleague. So ESA's Meteosat Programs Manager, Paul Blythe, he is in Kourou. He has been working hard on the launch campaign, and early this morning, he sent us this video.
I'm here in Jupiter. It's very early in the morning. It's actually about 6:50 our time. We've been here for about an hour. We've just started switching on the satellite. It's very quiet. I think it's what you could call the lull before the storm. But we had to get here early because our satellite switch on actually takes some time, and we need to make sure that we have some ways back if there are any anomalies. We actually tried to run the system 2 or 3 days ago. We didn't have any major anomalies then. Everything went like clockwork, but clearly on launch day we have to be sure. Anyway, so this is, I will show you, this is the control room. As you can see, it's all very quiet. The screens are down. There's 3 of us actually in here, including the mission director. The team has been brilliant. The Ariane Space team have been brilliant. They took us out to see the launcher last night by floodlight. We actually walked under the launcher. It was an absolutely incredible experience, one which I will certainly never forget. And it really is... It's a culmination for me of many, many years in the business, and I'm very honoured to be part of this. And I wish you all a good launch event, and assure you our end will be doing everything to make sure it is that.
Thank you, Paul. Well, thank you to Paul Blythe. And of course, the Jupiter control room is not empty right now as it was this morning. There are people there working, getting ready to get this rocket off the ground. Now, I hand it over to Chiara.
Now, while Peter and Paul and a few dozen engineers and scientists from ESA and Meteosat have been working very hard in the last few weeks in French Guiana. In fact, they have spent the last 4 weeks preparing, testing, and integrating the satellite. Now, while they've been having a very relaxing time on the shores of the Pacific Ocean, their friends and family here have been missing them a lot and are hoping that everything will go well. And I would actually like to speak to some of the friends and family we have here in the audience. So I'd love to turn to Audrun and Roxanne. Hi, thank you so much for joining us today. Who are you here to support?
I'm here to support Donny Amenou. He's one of the payload managers, and he's been on this project since ever. Because I hear that it's 12, 14 years since it started, but I know him since 17 years, and it's been there because he was there before the budget was arranged, before there was a team. So since I know him, the project has always been there, kind of.
And, I mean, he must have been traveling so much in that time. Could you keep track of where he was?
No way. Sometimes I was able, but many times I was not. So, what to do? Because you're supposed to know where your husband is, you know? So, I figured out by saying what he said about temperatures and food, because food is very important to Donny. He's French, you know, after all. And so, when he, for example, said, "Oh, I really hope we find a restaurant that serves funghi, I thought, you must be in Italy, in Florence, you know. And the same when he said, I don't eat meat myself, but when he said I had this huge meat with a bone sticking out of it, I thought, okay, you must be in Germany, because that's what it's served in Germany. And temperatures also. He's born in Africa, so staying in Holland is a challenge. And when he said, 20 degrees sunshine in November, I knew he was in Cannes. So without asking direct questions, I can figure out where he was.
Perfect.
So yeah, and I'm so relieved, happy that the traveling now is almost over. Yeah.
Thank you so much, Audrun. And now I would love to turn to Donny's daughter, Roxanne. Happy belated birthday, by the way. It was Roxanne's birthday yesterday. So, Roxanne, how is it for you to have a dad that's been working on satellites for most of your life?
Well, yeah, he has been working on satellites for most of my life. I'm just turned 25, and I've known him doing this my whole life. And I'm very, very, very proud of him, especially since he was raised in a very poor household. He came from Cameroon. He was born there, and now he's a big executive in ESA. So it's just amazing to me. That is really amazing. But what's funny is that most of the time when people ask me what my father does and I tell them, they are like, wow, your father works at ESA, oh my God, that is amazing, he makes satellites, it's so incredible. And I'm just like, yeah, okay, I mean, it's not that, because I've known, for me it's normal, it's regular, it's mundane, it's just, yeah. So, but I'm very, very proud and very happy that of his achievement now.
Fantastic. Thank you so much to both of you. Thank you very much. And now, back to you, Kelsey.
Well, thank you, Chiara. Now, of course, Peter, MTG-I1, it's the first in the family, and it carries 4 instruments. Maybe you can show us where these instruments are and talk us through what they do.
This is the FCI, the Flexible Combined Imager. That's the main instrument and the biggest one. You should never see it like this, because or the cover is closed for the launch, or it should be really open. This one is a continuation from the previous generation of satellites. They all had an instrument similar like this, but of course this one is much better. This is a lightning imager. It has 4 cameras, and together they see the whole Earth, as you can see from our geostationary spot. And they look in a specific band, such that they can see very well the lightnings. And on the back we have 2 antennas. One is the, sorry you cannot see it, one is the GeoSAR antenna for the GeoSAR system, and that is a search and rescue system that will receive and retransmit search and rescue signals, for example, from ships on the sea. And the last small antenna is the DCS, that's a data collection system.
Okay, well, Peter, thank you so much. We're going to let you take a short break, but you will come back up here on stage with us in a bit. Thank you, Peter. And now we're going to go over to Chiara, where she's sitting here with 2 representatives from companies involved in building some of the instruments that we just talked about. Chiara?
Yes, that's right, Kelsey. I am here with Alessandro Fumagalli and Antonio Gonzalez Elias.
Hi.
Welcome, both of you. So, Alessandro, you are head of the Space Systems Engineering at Leonardo in Italy, which is prime contractor for the Lightning Imager. It's new, it's the best. What's all the hype about?
It's the best, yes. No, we're very proud of it because it's a first of a kind in Europe, and as Paul always says, it's top class in the world. So it's a very important technology for the mission, and yeah, you know, by nature, we have to look at lightning. So by nature, lightning is a very, very fast event. So the difficulty there is to be able to catch this event, which and we are capable of catching lightning which lasts, which are as short as 0.6 milliseconds, which is much less than the blink of an eye. That's only one of the difficult parts, because we have to see and to look at lightning, to detect them in many different conditions. For example, we have to be able to discriminate between a lightning and its reflection over the sea, for example. Or if we're looking at something over a city, we have the lights of the city in the background, so we have to understand if we are looking at the light of an house or of the lightning. And we do this by a good piece of technologies, a combination of optical filters and algorithms that processes a lot of data. Because the lightning are fast, we have to be fast. And in fact, we scan the whole Earth disk in 1,000 times per second. So.
1,000 times per second, that's incredibly fast. Is that not too much to handle?
It is, yes, it is a lot, but not too much. Fortunately, we can handle it. Let's say a key technology of the Lightning Imager is that we processes all this data on board, and we actually send to ground only the images which actually contains the lightning. We do this with a lot of algorithms, and we think that this is the key technology and the most, let's say, technological advancement we have done with this instrument, which, by the way, has been very hard work. It took more or less 10 years of hard work from our engineers in Leonardo, in Campi Bisenzio, close to Florence, and we're very proud of it. And as we say, it's a good piece of hardware. Yeah.
Amazing. Yeah. And Leonardo has also provided the star trackers for MTG and major parts of its solar panels. So thank you again, Alessandro from Leonardo.
Thank you.
The other main instrument that Peter mentioned, of course, is the flexible combined imager. And Antonio, you are a system and control engineer at CENER in Spain. You guys built a component that makes more out of telescopic mirrors. What is it?
Thanks for the introduction. Well, my company, CENER, is building the scanners for two instruments, the imager and the sounder. To understand the importance of this scanner, we need to focus on the mission and the instrument. The Meteosat works in a geostationary orbit, 36,000 kilometers from the Earth. And from this perspective, it's like when you take a selfie with your mobile phone. The perspective of your face from the mobile phone is the same as the perspective of the Earth from the spacecraft. But in order to get full resolution, what the instrument does is to do a lot of zoom. So it incorporates a telescope for doing this. If we use the same example as the face, the size of the image would be equivalent to the size of a tooth. So to get the full view of the Earth, you need to scan the Earth. Okay, and you can do this in two ways. Either you move the full instrument, or you can also use a folding mirror. For example, in the second generation, they were using a satellite that was spinning about one axis. So this spin provided the horizontal scanning, and they use another folding mirror to provide the vertical scanning. For the third generation now, we are using a scanner, we are using a stabilized platform, and we need the scanner to scan in two directions, horizontal and vertical. The use of a stabilized platform prepared the ground for improved performances, and this is for two reasons. The first one is because we could introduce new instruments like the lightning imager and also the infrared sounder that they need a stabilized platform, not moving. And the second reason is because you can have a continuous view of the Earth with almost no dead times. These two reasons and improvements in the optical design has allowed to increase the data you download from the space segment by a factor of 15. So we have 15 times more quality data than in the previous generation, and this is a good improvement, isn't it?
This is a great improvement and just such a great example of what European industry is capable of. Antonio from CENER, thank you very much.
And now, I would love to pass it over to Kim Johnson, and if you don't know him already, you really should. He is over here with a group of social media representatives who are joining us tonight to follow the launch of MTG. How are things going down there, Kim?
Things are going great here, Chiara. Thank you very much. So indeed, here we are with the social media representatives, and some of them were able to apply, and some of them were invited to attend this launch event. And combined, they actually have a lot of followers and a huge, big outreach on the younger generations. And that's why we think, or we believe that for them, attending this MTG-I1 event is also important. Next to me here is Rocco Tortullo. He's a software engineer at the Royal Dutch Meteorological Institute and also the founder and creator of Meteosat. Rocco, good evening. What's it like to be here at ESTEC, and what are your first impressions so far?
Yeah, first impression, I would say in two words, wow, amazing. And yeah, I'm really happy to be here, to be part of this group of media creators. I think we are around 25 from different countries. And yeah, it's always nice. We had a great time since 1 p.m. We had a tour in the facilities of ESTEC. It was very nice to see how much work is done in this place. We had fun also with the quiz. So I didn't win, but it happens. And yeah, and we had also the opportunity to have an interview with some scientists from ESA and EUMETSAT. So it was so far everything nice, and I hope it will continue and be even nicer with the launch.
Well, very happy to hear, Rocco. Another question. Sorry. Yeah, is this the first time you're following an ESA launch, actually?
No, it's not my first time. I was in ESOC and again also here in ESTEC for the Sentinel launch, more than one. So yeah, and every launch event is different. Everyone is nice. But I think today will be nicer because it's the beginning of the new generation, so the third generation of the Meteosat satellite. So, and I hope, again, the launch and the mission will be successful.
Thank you very much, Rocco. Also next to Rocco, we have Dr. Clara Nellist. She's working at CERN, and she's a particle physicist and also a science communicator. Now I would like to ask you, Clara, what would be the first thing you would like to share about this event to your followers?
Well, first of all, I want to echo the comments. It's been a fantastic event. It's been really exciting to see behind the scenes and to see some of the testing facilities and what the satellites have to go through before they even get to launch. So that's been really interesting. But also, one of the questions I always get asked on social media is, how does this affect me? And I think this satellite is a really great example of how this is going to really affect people right away. It's going to save lives, for starters, but it's also going to better predict lightning events, forest fires, climate change. It's a really important piece of technology that's going to improve lives right away.
Very clear. Thank you very much, Clara. Well, back to you, Kelsey.
Thank you so much, Kim. Now, to those of you who are just joining us online, we are live, broadcasting live here from ESA's technical heart, ESTEC, in the Netherlands. We are getting ready to watch the launch of the first Meteosat Third Generation satellite, and that's going to happen at about 9:30 local time here in the Netherlands. Now, joining me on stage is Jochen Grandel. He is the MTG program scientist at EUMETSAT. Now, from a science and data point of view, what is the reason for a new family of satellites rather than pushing the evolution of the existing ones?
Well, as has been already said, it's a kind of a system of satellites, first of all. So we just don't have just this one, we have also the other one coming up later. And it all starts from the user requirements. So our users, that is the weather services usually, they give us a set of requirements that we need to fulfill. And that starts from a continuous of the existing service. I mean, this has to be, let's say, proven. And this we have definitely achieved. But on top of that, we also need to do something more. So we have to gain, let's say, more on the existing one. And that comes from the development of the need of the data, from the model development, for example, that we need for the weather forecasting. So that needs more advanced data that we can have currently. And so that is, and also taking into account that this is data for decades. So we cannot just, let's say, keep the satellite data, let's say, constant or flat and not achieving something new, because everything else in the weather community is, let's say, advancing. So we have to go hand in hand. And that's what we are doing here.
About going hand in hand, of course, today we're launching MTG-I. Tomorrow we have the one that has the sounder on it. And with the data from the two, will they complement each other?
Yes, definitely. They go really in hand. So what the sounder is doing has been mentioned already. It kind of makes a 3D image, a kind of slices the atmosphere, which we cannot do currently. The imager is, as the name says, doing an image. It does nothing more than the image, which is also very, very, let's say, capable. But the sounder is much more than that. And actually, as a real-life example, what it means is that we have a situation of severe weather forming at some point. And that starts with so-called instability in the atmosphere. That is something we cannot see with our eyes. That can only be seen with these kind of measurements, and where we slice the atmosphere. And when we know that, we can start looking at this area more closely with the imager, for example, then later. And then the lightning imager comes and actually completes the story, because then we can follow the lightning and see how that develops. And that is very important, because not all storms are, let's say, life-threatening or dangerous. Some are. And with this data, we can really achieve this kind of knowledge.
And is data the only ingredient we need for better weather forecasting?
No. There's definitely the human factor as well, which is quite important. I mean, I'm not a forecaster myself, but if I were a forecaster and I work alone in my office somewhere in the middle of the night, something bad is happening, and I have the responsibility of saying that, do I issue a warning or not? A severe weather warning, which has great, let's say, implications. If I don't do that and something bad happens, it's quite bad. And so this is really giving the confidence to the forecaster of actually doing a proper job there. I mean, of course, they have the skill and the experience and all the other data that comes along. I mean, it's not just satellite data they use, but all that together actually gives you this confidence for the forecaster to actually give this warning or not.
Exactly. Well, it will be a new era for weather forecasting once we have both of these satellites in orbit. Jochen from EUMETSAT, thank you very much for being with us. Now, I want to know, where did Chiara go?
Over here, Kelsey. Hi. I have someone I must introduce you to right now. So over here, we have Ruud van Reyerdahl. He's an artist who is drawing a record of our event. And it's really worth keeping an eye on this whiteboard over here as he fills it up with all the information. So we can already see the launch and, of course, MTG-I1 over here, and some of the components that our speakers have already talked about. So the FCI, the Lightning Imager, and the sounder, and it's looking fantastic. So we will certainly come back to you again, Ruud, because that is why we are here, to bring to light why MTG is so needed.
That is absolutely amazing. Now, Chiara, why don't you join us back on stage, because right now I have Peter van de Brambusse, for ESA's MTG Satellite Systems Manager, joining us. Also, Claudio Bruno, he is the Director of Earth Observation Programs at Thales Alenia Space, as well as Dirk Schulze, a member of the board at OHB Systems. Now, Peter, ESA has defined the new technology for MTG, but the hardware is designed and it's built by European industry. How many people were involved?
That's correct. ESA defines the requirements and industry builds the instruments and the satellites. In total, 200 companies in Europe were involved, and that's several thousands of people. And Thales Alenia Space was the prime contractor, and they were also responsible for the MTG-I satellite. Would also like to say that they take care of the image quality tool together with GMV. That's the software that we will use in the first months to process the data. And OHB, they are responsible for the MTG-S satellites. That's the next one we will launch. But they also build the platforms for all the satellites.
Thank you. Claudio, your role is that of prime contractor, and you have also built the main instrument. Now, this sounds like an awful lot of work. Did Thales Alenia Space do this alone?
As a prime contractor, we received the engagement to coordinate an important industrial complex team. And as all the ESA programs foresees, when you have prime contractor, you are responsible to coordinate the team, the industrial team. So consider that 16 countries were involved, with about 70 companies and 200 subcontracts. So this means that, as a matter of fact, the entire Europe was involved in that. And coordinating this team means also coordinate companies that could be in other scenarios competitors, but they will work together for the final result. And this is one of the major undertakings that ESA is able to propose to the industry, is a real success for this.
Fantastic. And now, Thales Alenia Space is, of course, a big player in the satellite industry and has been for decades. How did the generations of Meteosat improve?
But consider that since from the 1977, when the first Meteosat was launched, Thales Alenia Space was prime contractor for the first, the second, and now the third generation. As we know, this morning we understood that this MTG-I1 will become Meteosat 12. And this is a real indication of the evolution of the Meteosat endeavor. Consider that Meteosat first generation was able to take images every 30 minutes. The second generation every 15 minutes. And now we are able to go with the third generation every 2.5 minutes over Europe and 10 minutes over the entire Earth disk, in this case including Africa.
That's incredible, and yes.
This is a huge improvement for that.
Thank you so much, Claudio from TAS.
Now, Peter, the shape of MTG is fundamentally different from previous satellites. Why is that?
As was said before by Sener, the previous generations, they were spinners, so that's why they have a cylindrical shape. And you need to know that the detector for the FCI, and that was the same for the detector of the instruments of the previous generations, is not a square, it's a vertical line detector. So it's important that you scan from east to west. And with the spinner, you get the scanning automatically because it's spinning. In addition, the spinning gives you gyroscopic stability. So this is a very stable satellite. The drawback, as was explained by Sener, is that you see the Earth only 5% of the time. Most of the time you see deep space, which is not very interesting for weather forecast. That's why we wanted to go to a stable satellite to actually stabilize. But the problem is that to have this scanning, it's a very nice scanner that Sener built, but it is a mechanism inside that disturbs. So it's something moving, and so it's difficult to keep it stable. And in addition, you lose the gyroscopic stability from the spinning. So it was a challenge, but we have confidence.
Great. And now what we'll see shortly on screen over here, ladies and gentlemen, is the clean room at OHB, where the imager instrument is finally packed and mounted. So let's go to Dirk Schulze from OHB. Dirk, there are a few large players in the space industry in Europe, and of course they are big competitors, and yet they collaborate on such big projects. So how does this all work out?
Well, sometimes it's easy, sometimes it's difficult. When I remember the early days of this program 12 years ago, we were close to having a deal with TAS. And TAS invited us to a nice location on the hills above Cannes. Yeah? Nice restaurant. I've never been there, and I'll tell you why. Because we were not there yet in our agreement, because contractual stuff would need to be figured out. So 3 of OHB and 3 of TAS were sitting in this windowless room in Cannes, trying to make the deal. And we negotiated through the day, and then the evening come, and all our folks left for the fancy restaurant in their buses, and we couldn't figure it out. So we skipped the antipasti, we skipped the main course, and then my boss told me afterwards, who was sitting in this restaurant, with the right hand, he was holding the wine glass, raising a toast on the collaboration between TAS and OHB, and with his left hand, he was text messaging to us, hold your line, don't give in. So, and ultimately, we failed that evening. Despite the celebration event, we couldn't make a deal. And I remember, and this is one of the great coincidences in life, when we left the TAS premises and we were entering the parking lot, it must be around 11 at night. And we were in a mixture of adrenaline from all this negotiation and then disappointment and not knowing what to do. And then the bus came back with all the folks from TAS and OHB. And they were in a pretty good mood, a bit tipsy due to the wine, and they left the bus and hey, do we have a deal? And we said, no, there is no deal. So, and then I never forget the eyes of one of our TAS colleagues from a commercial department who couldn't believe that we still haven't figured it out to close that deal in that evening. So it was a failure for us, but ultimately we got it done.
What a story. I would like to thank you all very much. Thank you, Claudio from TAS, Dirk from OHB, and Peter from ESA.
Thank you.
Yes.
French Guiana, home to Europe's spaceport on the edge of the Amazon jungle, and it is where MTG right now is waiting on top of an Ariane 5 rocket poised for liftoff in about 1 hour from now. It is, of course, daytime in Kourou, so we are expecting some spectacular views when we do get to time of liftoff, if everything goes as planned. Now, ESA's Director of Earth Observation Program, Simonetta Kelly, is there in French Guiana, and just a few hours ago, she sent us this video message.
Dear guests of this ESTEC events, dear colleagues, dear delegates, and dear partners from industry and all the partners from EUMETSAT to this mission. We are here in Kourou. We are just in the final stages before the launch, so quite emotional, I must say. We went to the launch pad, saw it from very close this morning. We could feel the tight professionalism, but also the emotion of everybody who has worked for years on this mission. My colleagues at MTG team, more than 12 years of work together with EUMETSAT. Everybody is here ready. Now the Meteo is green. We're in the last 5 hours to the launch. So everything looks ready. From the technical point of view, everything is ready. The launch looks okay. The Meteo looks okay today. And we really look forward to this new step in meteorology and in our programs. MTG-I, in fact, it's a next generation of meteorological missions. It's a new start after MSG and after all what we have done in meteorology for the last 40 years with EUMETSAT. We look to the next 20 years. It's a mission with a lot of innovation on board, a lightning imager which has been built with a lot of work, an effort by Leonardo. The prime is from Thales, of course, but also lots of work from OHB in the satellite. The lightning imager will give a lot of new data about cloud-to-cloud lightning. This is very relevant. And then the flexible imager will give a lot of new data on everything that's related to nowcasting. We need data faster, more resolution, and that's all what MTG will bring to us for the next 20 years. We really look forward to this launch, and I wish to you at ESTEC that we are connected very closely with the spirit and with the mind in the next few hours and minutes.
Well, thank you to Simonetta Kelly, Director of ESA's Earth Observation Programs. Now let's stay for a minute in Kourou, where teams have been busy for the past weeks getting everything ready. Behind me, you can see a time lapse of the satellite being prepared, and then we'll see it being encapsulated on top of the Ariane 5 rocket. Now, this flight has 2 telecom satellites on board in addition to MTG. Everything has to be tested, it has to be checked, adapted, and made ready for flight, which, by the way, is a violent ride into space. Now, with us on stage, we have Kate Underhill. She is the Upper Stage and Propulsion Project Manager at the European Space Agency. Kate, can you please talk us through the launch? What is going to happen after countdown?
So the launch happens in French Guiana, as you know, so the countdown is in French, 10, 9, 8, and then we get it down to 0, top. And Ariane 5 is a bit of a special launcher. It doesn't actually take off at T0. What we do is we ignite the main engine, the Vulcain 1, which is missing from my model here. It's an old model I have in my bathroom. Vulcain 1, 2.1 ignites, and we check out the system. We make sure it's working. The launcher checks it's working, and when the launcher is happy, the parameters are correct, then at H0 plus 7 seconds, then we ignite the solid boosters. They're on the side. Now, Vulcain 2.1 has about 1.4 megatons of thrust. Seems like a lot. The boosters, it's 5 megatons each. So they're the ones that take us off the ground, get us off the ground against gravity, and take us off. Once we've ignited the solid boosters, it's 240 tons of solid propellant burning for about 2 minutes. And then the thrust will reduce. That gives a signal to the launcher to separate the boosters. The boosters drop off, and now it's just the main stage, hydrogen and oxygen. So this is liquid propulsion, the most performant propulsion we have. And it's burning for about 9 minutes. And then the main stage will drop off. During that time, plus 3 minutes, we're about 100 kilometers altitude already. So take off to 3 minutes, 100 kilometers altitude. We're out of the atmosphere, then we can get rid of the fairing. So the satellites are now out into the open. And it's the upper stage, the cryogenic upper stage of the HM7B engine that is flying for about 15, 20 minutes, depending on the mission. And then we do satellite separation. And this is called space ballet. It's a very delicate operation. It's no longer the main engine's cut off. We've now got a special control system, use coal gas, hydrogen, that's delicately positioning the upper stage to separate the satellites. As you said, we have 3 passengers today, plus the system called a CILDA, which is the double launch system. Separate the first satellite, reorient again, separate second satellite, reorient again, get rid of the CILDA so that gets out of the way, and then finally we separate the MTG. That's the end of the mission for satellites, and then the upper stage will go and what we call passivate, get rid of the propellants and put itself into a safe orbit.
Okay, well, here in Europe, of course, we were familiar with this upper stage, but it became world famous with the launch of the James Webb Space Telescope in Christmas last year, when that was launched on Ariane 5, and the upper stage really did something special for James Webb. Tell us about that.
Well, overall, the launcher, Ariane 5 has been an amazing launcher, and James Webb was a great publicity for what we can do in Europe and for the launches in Europe. Ariane 5 did an absolutely perfect launch on Christmas. It was a Christmas present for the European Space Agency. We launched James Webb into a perfect escape orbit towards the Lagrange point where it's now arrived. And because the orbital insertions, we got the position, we got the direction, we got the velocity so good that James Webb used very little of its propellant in the correction maneuvers to get into final orbit. It was built to last for 5 years. They put enough propellant in it for 10 years operation. They now think they can have 20 years of operation because of the fuel reserves we have left.
Well, that's excellent. Well, we are looking forward to this launch today. Kate from ESA, thank you very much.
check my phone in the morning and look at the weather app, I often doubt it and think, might be better to bring an umbrella even if there's no rain on the forecast. But now with me, I have Jenny Rourke and Professor Gerhard van der Steenhoven. Welcome. Now, Jenny has been a weather forecaster at the UK Met Office, later at ECMWF, and now she is head of the real-time services at EUMETSAT. Jenny, why can weather not be forecasted more precisely?
Well, I mean, a good example is what's been talked about a lot today with thunderstorms and showers, for example. If you think about when you heat a pot of water, you know you're creating an unstable atmosphere in your pan, but you don't know exactly where the bubbles are going to pop on the surface or exactly at what time. And it's the same sort of thing with weather forecasting. We're very good at predicting an unstable atmosphere, but some of the details around where the thunderstorms or showers will develop is still hard to pin down.
Now, Gerhard, when we talk, Gerhard is the General Director of the Dutch Weather Service, KNMI. Now, Gerhard, when we talk about weather, we often refer to our tiny environments, maybe our homes, where we're going to work, and you are focusing on these mini clusters. What is the role of MTG at this small scale?
Well, the importance of weather forecast is mostly focused not so much maybe on the daily weather, but on the, on the extreme weather forecast. When there is really high impact weather, that's when a national weather service really has to step in and make sure that as many people are properly warned as possible. And that's where localized, very precise, good information well in advance is crucial in order to fulfill our missions as national weather services, and that is to reduce losses and damages due to extreme weather and climate change. And that is where MTG, I think many of the previous speakers have already emphasized that, really steps in. Because if you know the information from space earlier and more precisely, you will be better able as a national weather service to warn people and not just warn the entire area of the Netherlands or just the province, but really just that part of the Netherlands where this extreme weather event will hit.
Talking about the clusters and now looking a bit more globally, because we always look at our weather, of course, here in Europe, but this satellite covers half of the globe. So do you have any examples of elsewhere in the world, Jenny?
Well, obviously, MTG sat over Africa. There's areas such as Lake Victoria, where you've got fisher people going out at night to fish and for their livelihoods, and there can be very dangerous thunderstorms that develop over the lake. And I know that the National Met Services there are trying very hard to issue very timely warnings to try and save people's lives, to say don't go out on the lake tonight. And that's exactly where MTG is going to help provide additional vital information for the forecasters in those regions.
So we see that a major need nowadays is nowcasting. Could you explain a bit more what that is?
So nowcasting is that initial period, that first half hour, a couple of hours, when it's very vital for looking at the development of a thunderstorm, for example. So Meteosat Third Generation is going to provide us more timely information, as has been mentioned, and at higher resolution. So the forecasters are going to get even a couple of minutes extra warning of the development of a severe thunderstorm can be incredibly helpful to make a decision to issue these warnings.
Now, Gerhard, is KNMI prepared for MTG data?
Sure. But of course, it is, I mean, we should not create false impressions, because it will still be quite a bit of work to make sure that all the instruments are properly calibrated, all the connections are properly made. So people at my institution, but also, of course, at EUMETSAT and the various NMHSs throughout Europe are, of course, very much busy to make sure that the data are used in various ways, that they can be displayed on our screens in the weather rooms, and that they are assimilated, a bit of a technical word, into the weather models, such that those weather models are making use of those improved data. And all of that work, at least in my institution, is in full flight. And given the fact that well, all these processes take a while, I assume that we will be completely ready by the end of next year to make perfectly use of the new MTG-I data.
Good.
Fantastic. That is great to hear. Now, despite all the critics, weather forecasting has made a great difference in the past decades. Jenny, is there anything you're particularly proud of?
Well, sometimes it goes beyond what you'd consider weather as well. I mean, the derived products that come from the Meteosat satellites include things like the dust imagery. You can see volcanic ash quite clearly. And I know at the volcanic ash advisory centres around the world, they use the imagery to be able to detect the dispersion of volcanic ash and things like Saharan dust, which can cause a great hazard to aviation. So using Meteosat imagery, they're able to help aviation keep safe and avoid this hazardous material that's in the air.
Now, Gerhard, the Netherlands in particular is very dependent on weather forecasting, but also as a low-lying country on precise climate change modeling. How will MTG help here?
Well, there are various ways how MTG will contribute to the knowledge about climate change. The first issue is that, of course, as we all know in this audience, it is the third of a generation, so we are already taking this type of data for several decades. Excuse me, and that's crucial if you want to understand climate change. You want to study the same phenomena, the same weather for a period of at least 30 years, preferably longer, in order to really fully understand what climate change is. What I find particularly attractive of MTG-I1 is this lightning imager. It has certainly been mentioned earlier tonight, and the idea is that you will have a picture of all the lightning events that take place from the other side. That's not from below, but from above, and to further study in that way what climate change does. I mean, is climate change affecting the amount of lightning? Is there an increase? Can we use the lightning to better understand the intensity of storms developing? So there is a second aspect, and that is, of course, that climate change leads to more extreme weather. And by studying that, we hope to improve our forecast in a generic way, not only on the, let's say, nowcasting way that you explained a minute ago, but also how extreme weather will develop in the future, decades from now. Very important, because even if we stop with CO2 emissions tomorrow, the further change of the climate will continue for at least a century.
Okay, well, Gerhard from KNMI and Jenny from EUMETSAT, thank you so much. I'm now going to hand it back over to Kim Johnson, who is there with a group of social media representatives. Kim?
Thank you very much, Kelsey. Now, we've been talking about climate change, global warming, weather forecasting, extreme events, etc. These are important topics, but also big issues for the younger generations. And for this reason, I would like to introduce you to Kate Amanda. She is a PhD researcher and specializes in remote sensing and GIS. Besides this, she also has a whopping 33,000 followers on Instagram. So, Kate, good evening. I would like to ask you, what is an important or interesting thing you learned about MTG today, and what is a message that you would like to pass on to your followers?
Hi. Firstly, I want to say how amazing today has been as well. Having an insight into how the satellites actually get into space is incredible. But yeah, probably the main thing for me is the fact that it's a geostationary satellite and it can give a temporal resolution of 2.5 minutes. So in terms of predicting weather, that's great, because a lot of my followers are part of the adventure and outdoor community, so I'm sure they'll be thankful for having better predictions in weather. So yeah, that's probably the main thing for me.
Great, thank you. Another question for you. What is for you, or why is this satellite so important for you, and why would it be important for the younger generation as well?
So yeah, probably to echo the climate change topic there. So my main interest and passion is monitoring climate change. So this would eventually allow the younger generation to have a historical data set over time. Again, with being able to predict satellite lightning, it would be able to show the implications of climate change on storms and stuff like that. So I think that's great for the younger generation to bring in the future. Whether it might be too late, we don't know. But yeah, definitely that.
Important message. Thank you very much. Now, if we rotate a bit back, then next to me we have Dr. Tim Gerrits. He's an expert on scientific communication and visualization, and I would like to ask Tim, how does the communication on climate change affect the awareness and perception on climate change?
Oh, that's actually a bit of a tricky question, because we can talk about communication between scientists, and that's a little bit what we did today. We had the chance to talk to people who are involved in this project, and that's been amazing. But I think what's much more interesting is how we, as a scientific community, communicate the latest insights that we get on climate change and climate research to the public, because that, I think, has made such a huge impact over the last few years, how giving people tools to look at the data, see patterns, see trends, that's what sparks discussions. And those discussions are actually what I think can change society in a way, and that's, I think, what we've seen over the last few years in terms of how urgent people now see we need to act. And yeah, I think that's why, that's all based on communication, so it's important, and today marks a good spot to see that we're trying to make a good job about that, right?
Yes, very important and very clear. Thank you very much, Tim. I'd like to give the word back to Kelsey.
Thank you so much, Ken, and thank you to our representatives from social media. Now, the first Meteosat mission was launched in 1977. That was 45 years ago. Not all of us were born then. Climate change was not such a known issue in the 1970s, but building a satellite, the first satellite to see weather, the first European satellite to see weather, that was a revolution. A man who worked on the very first US weather satellites in the 60s and then became responsible for the radiometer on board Meteosat 1 in 1971 is Mike Reynolds. I think some of you in this room do know this name. This was at the time... This was at the time that ESA was still called ESRO. Now, Mike retired in 2001, but we got the chance to speak with him on the phone about those early days of spaceflight. He told us how the program all started off. Let's listen.
Meteosat was basically the European contribution to what was intended to be a global geostationary observation system. And the idea originally was that the Americans would put two satellites up, one on their east and west coast. We'd put one up over Europe. The Russians would put up one over Asia. And the Japanese would put one up to make a total ring around the world. But for various reasons, it never got there. It was just part of a global concept initially.
The early days of spaceflight were quite experimental. How was it for Meteosat?
The first flight units were determined to be scrapped by our quality assurance people. They took one look at them and said, no, these can never fly, they're horrible. And I said, well, they're going to fly because we haven't got any alternative. And they did fly, and they never caused any problems. But I must say, they did look horrible, really bad. I can remember the photographs showing bubbles underneath contacts and all sorts of things. But anyway, it was a different era. There was a lack of a lot of technology. We didn't have any microprocessors.
At the time, was Meteosat expected to be a big step forward?
It couldn't happen immediately because the meteorological forecasting depends on models, and if the models can't take the data, then it's not of much use. So it took a while for the meteorologists to develop all of the modeling capability to absorb the data. That was a gradual process as the data became available. Without satellites, there's no doubt that meteorology wouldn't be where it is today. That's quite clear. But you can't just claim that satellites on their own have caused the advancements. I mean, many things have caused the advancements, and in particular, the capability to model the atmosphere has produced vast steps forward.
MTG is much different compared to the satellite you initially worked on.
It had to happen sooner or later. I mean, for the second generation, we initially were looking at a three-axis configuration. And the reason why we didn't go down that path was simply cost. There are some strong and difficult technical challenges, and this we knew. I studied for ESRO a three-axis system way back in the early 70s. And even at that time, we realized that even just on paper, this just wasn't going to happen very quickly. And it took a long time to get there. I take my hat off to the lads who've managed to achieve it.
Now, Mike, what is it that you remember most about the launch of Meteosat 1?
The number of stories I could tell you about Meteosat is infinite. But when the first satellite was launched, which was quite a drama in itself, the satellite was integrated with the launcher. The countdown was going on. And suddenly the Americans, they called a halt to the launch. And it turned out they actually detected a command-destruct signal being transmitted from somewhere. So they refused to launch until they'd found out where the signal came from. Now, it took about a week when the man that was responsible for the transmission of that signal heard about the story of this launch delay. He was on holiday in Mexico, and he rang from a telephone booth to say, look, I think it was me. I think I tested the command-destruct circuit So they made him stand in this telephone booth with the Bible and swear that it was him that had created this problem, and then eventually launched.
Well, swearing on a Bible in a telephone booth, that's how we got a satellite into space back then. Mike Reynolds from the UK, thanks so much. That's you, Chiara.
Now, speaking of people that weren't born yet, I am here with Aravind Ravichandran. Welcome, Aravind. You run a startup company called TerraWatch, and you look at the weather forecasting market from a business point of view. Why is weather forecasting a market?
Well, thanks for having me. Well, weather forecasting, of course, it's, we've talked about the impact of weather and the MTG mission a lot, but, obviously it has, commercial potential attached to it. And whether we're looking at industries like energy, it's becoming a hot topic today in Europe, and I live in France, where, power cuts are almost becoming a reality, which means that, companies and industries need to know in real time, that's casting, how the load shedding is going to happen. So, that's one example. Another, which is very conventional, is insurance. Insurance companies are building parametric insurance models that are very, very dependent on real-time weather data, so that they can update their models and, help their claims. Those are two traditional industries that use weather data, but then there are also like non-traditional applications coming up. Think about ordering a taxi. A taxi company. It needs to know the weather in order to make sure that there are enough drivers over a locality to make sure that they can, meet the demand. The supply needs to be there. It applies to, all sorts of, things that we order on the app. That's one application that, again, we don't think of. Another is probably things that we order online. You see, the estimated shipping date. That depends on weather as well. We don't really associate that, I think, as individuals. We just look at our weather app and, assume that's basically the application of weather. But of course, as a consultant and as a communicator, part of my job is communicate that weather market to investors, but also to end users, to make sure that they understand that there are commercial decisions that they can make with data that's coming online now, like with MTG, that was not possible before. So yeah, absolutely, there's a big commercial market that's a lot of studies have estimated to be in billions of dollars, of course.
Thank you. Those were very good points. I mean, there are more touch points than you can even imagine.
100%.
So thank you very, very much, Aravind from TerraWatch.
Thank you.
Ladies and gentlemen, to those of you who are joining us online, once again, we are broadcasting live from ESA's Space Technology Center, ESTEC, here in the Netherlands. We are getting ready to watch the upcoming launch of the first Meteosat Third Generation satellite, which is planned to happen in less than an hour from now. And as we were talking about the mission, the technology, and the benefits for weather forecasting and business, we haven't really dove into the topic of climate change monitoring, which ESA and EUMETSAT are both very much committed to.
Yes, that is a very good subject. And right now, I am very happy to have here with us Susanne Mecklenburg. She is head of the ESA Climate Office. Welcome, Susanne. And we have Joachim Seimüller, the EUMETSAT head of user support and climate services. Welcome, Joachim.
Hi there.
Now, Susanne, thanks to people like Mike Reynolds and many others, we can look back on 45 years of Meteosat data. Why do we need this for climate monitoring?
Well, climate, of course, is a long-term phenomena. So in order to understand what the state of the climate is and how it's actually evolving and changing, we need to have decades of data. And MTG is a constellation that gives us actually that chance with already more than 45 years of data available, and many more to come with this new generation here. It's important also because these space data form the basis for what we call climate data records. So these are long-term data sets that are based on a definition for climate indicators. It's a very technical term, essential climate variables, that have been defined by a group of eminent scientists from the Global Climate Observing System, for example. So it's important to have these long-term data sets. And in the example from MTG, we are already using the sort of pre-instrument to the FCI Severi, which is on MSG, on the second generation, in some of our data sets in the ESA Climate Change Initiative for land surface temperature data, but also for clouds and maybe also in future for aerosols. So that's really important. And this continuity that a series like MTG provides is really important. And today we were talking about the imager, but as part of this constellation, we will also have the sounder. And the sounder is carrying the Sentinel-4 instrument, which will look at trace gases and aerosols and so on. And that's important as well because Sentinel-4 belongs to the family of Sentinels, which are dedicated satellite missions under the Copernicus program, which is a joint venture between the Commission, ESA, and EUMETSAT, of course. And that really gives this sort of continuity and outlook for decades of data to come, which will also instill our trust and trustworthiness of the data that we are supplying for the discussion around climate and climate change.
Okay, and yes, as you say, we have some instruments that we have seen on previous ESA missions. Some are new. Is this what we need for climate monitoring, this sort of variety?
Yes, definitely, because these essential climate variables, the climate indicators, there's over 50 of them that have been defined, and they can 2/3 of them roughly can be derived via space data. The rest is coming from in situ data, a bit of modeling, etc. But it's important to have this variety of different parameters so that we actually understand the whole Earth system and the Earth climate. It's important to look at different aspects of it. The lightning imager, for example, is a very exciting new development as well, because lightning is actually a climate indicator, possibly telling us something about, the increased occurrence of severe storms, for example. And so maybe in the future we will base our new climate data records on this as well.
So, Joachim, how did climate monitoring become the job of weather satellites?
Well, luckily it became that job because de facto what is monitored from the very beginning are essential climate variables. Now, also in the 1970s already the whole debate about global climate change was emerging, and I think we have come a very far way since then. I think it was alluded to by previous speakers already that with every satellite generation, we get to finer scales, and there is an impact of climate change onto the weather scale. And I think we want to understand with every mission better what those impacts onto the weather scale, so on really high impact weather is. So cloud climatologies is one example. So if we look back, we have now a time series, a climate data record starting in the early 1980s. Luckily, those data were kept, so we have them on the archive. We have built the infrastructure to actually reprocess those data, and we can now do things like energy analysis. So if you look at where you want to place your solar array on your roof or your power plant, you can look into Meteosat-derived data records in order to site those infrastructures, but also in order to operate them. So when is there rainfall with a high aerosol load from Saharan dust, for example, that smears onto your panel and these kind of things. So I think we have a very good period behind us already. And with MTG, if we look at that, the essential climate variables were alluded to. I think we have 54. I think MTG alone will at least cover another 21 of them. So we will be able to extend 21 of these ECVs with MTG alone.
Thank you very much for that.
Now, Susanna, aside from being used by the scientific community, Meteosat data are also used by politicians when they're discussing climate in places like Sharm el-Sheikh, in Bonn, or in Paris.
Yes, that's true. So what we're really doing with those data, and not just MTG, I mean, with the whole fleet of space data that we have, to which now MTG is obviously contributing in the future, it gives us the physical evidence of what the state of the climate is and how climate is developing and changing. ESA's role is very much in the R&D, in providing the food chain to arrive at climate-relevant information. So we're designing and building the satellites, and then we're working with our partners, for example, for the operations and the provision of data. That's really important. The important bit, though, is to make that link to the policy. And I think the climate change has become, the biggest threat to mankind, and this realization has become even more important over the last decade or two in particular. In 2015, we saw the Paris Agreement being put in place by the United Nations Framework Convention for Climate Change. They basically try to get everybody signing up that we should keep global warming to well below 2 degrees centigrade. And this is something where we need to actually measure how we are doing. So 2023, for example, is a very exciting year in this context, because we will go to a global stocktake where we measure where we stand with all our emissions. And that was will give, again, all the nations that signed up for the Paris Agreement an idea of where they stand in implementing their national targets for net zero, for emission cuts, for adaptation plans and so on. So it's really important to do that and to work with our scientific counterparts also in the Intergovernmental Panel for Climate Change, which sort of provides the gold standard for where we stand with climate.
You mentioned a very good point on the implementation, because aside from these political discussions, Joachim, how do these data help mitigate climate change in more practical terms?
So the photovoltaic example I mentioned already, I think there is another one that is more related to the efficiency of the transport sector. So there was a lot of alluding to routing planes more efficiently so that they consume less fuel. There's also a lot better information about low-level clouds and fog, so that's important for land-based transport as well. But all in all, I would say it's not only for mitigating climate change, but also for adapting, because again, the impact of climate change onto the weather scale and to better prepare for high-impact weather with better weather warnings is one of the main achievements that this mission will have.
Great. Well, thank you so much, Susanna from ESA and Joachim from EUMETSAT, and keep up the good work.
Thank you very much.
Now, ladies and gentlemen, as we are a bit more than half an hour away from the launch of MTG, we would like to have a look at Fucino in Italy, where the first signal of the satellite will be received once in orbit, and where the solar array deployment will be observed.
That indeed is a major moment after launch, because no solar panel means no energy, which means no mission. So let's now go to Gianni Ricobono at the Fucino Space Center. He is the Fucino Space Center manager, to see how things are going. Dottore, buonasera. Siamo felici di averla con noi.
Nice to hear you, Kelsey.
Now,
and
Gianni,
good evening to everybody.
Gianni, good evening. Now, one of your many antennas there on the Fucino plane will be pointed at MTG once in space and receive its signal. When will you start taking over the satellite?
We will taking over the satellite after the separation, so after 35 minutes after the launch. And the first antenna that will be in contact with the satellite, it is the antenna in Malindi ground station. So a few minutes before the separation, after 24 minutes from the launch. That will be the first important moment when we can acquire telemetry data from the satellite. After the separation, there will be the other important maneuver, that is the opening, the deployment of the solar array and the pointing of the satellite towards the sun to start charging the battery. This is another important moment. All these sequences have been preloaded on the onboard computer, and we will monitoring that all these sequences will be accomplished correctly. Then we will start to uplink the first telecommand. So it means after 1 hour and 25 minutes from the launch. That will be the moment in which we will start our work that we have prepared for so many years. So we have this LEOP has been prepared in really a long period, starting in 2017 with the development of the satellite control center, passing for preparation of more than 600 flight operation procedure, both for nominal contingency scenarios. We have tested and validated all these procedures together with the EUMETSAT people until last July 2022. And we have exercised all the teams in a long simulation campaign that finished a few weeks ago by the end of November. Consider that the last rehearsal was done last week on a Thursday. So we are ready to start with this LEOP. That is a really important LEOP for us. It's the first with EUMETSAT. We have quite a long experience in LEOP. We started in 1996 with Beppo Sachs, that was a scientific mission of the Italian Space Agency. And in all this year, we had more than 50 full LEOP and almost 250 LEOP support. But this is one of the most important that we are doing.
Well, time is running short, so Johnny, thank you. We will check in with you in about an hour after launch when we have to check on the solar array deployment. So for the time being, in bocca al lupo, or good luck. Now, where did Chiara go?
I'm back here, Kelsey. I just had to check in with Ruud again and see how the whiteboard has been developing. So we see he has added a lot more elements from what our speakers have said of all the different implications that this data will have. And this is a new way of working with data. So back to you, Kelsey.
Thank you, Chiara. So Sean Burns, in the meantime, has joined me on stage. Welcome to you, Sean. You are the Director of Operations and Services to Users at EUMETSAT. Now, after launch, what needs to happen to the satellite before it can start delivering data?
Well, there's a lot of things that need to happen. First of all, as we heard, we'll have the LEOP phase. So this will look after the satellites and do the first initial operations. And then we will also start to receive some data ourselves in our control center in Darmstadt. And then we get the satellite ourselves, get handed over on Boxing Day on the 26th of December. And then we can start with all the operations to actually command the satellite, to start to turn on the instruments. There's a lot of operations we have to do. We have to do some decontaminations of the satellite, of the instruments. We'll start to receive the data. We have two different stations to actually receive the data. One is in Leuk in Switzerland. The other one is in Lario, which is also in Italy. They're actually separated, so we should never miss any data in case there's any local weather systems interrupting the downlink. So we'll always get this important data. And then we have to fully characterize the instruments. And we use this characterizations when we finally get to send out the data to the scientists, who will then really look at the data, make sure it's what we want. And then finally, we'll be able to send all this data out to a wider community. And hopefully, in 1 year from now, we'll have a fully operational service to users, very high availability, very high quality, 24/7, 365 days a year.
All right. Well, before the data is ready to be delivered, how do you prepare your user community?
Well, we've been preparing our users for years. So we've got a dedicated project, a user preparation project. We've had dedicated conferences, workshops, webinars, online, of course, during the pandemic, which made our life a bit more interesting. And also in person. We had a fantastic set of conferences earlier in autumn, which was great to bring people together to learn about our data. So we're teaching them how to actually access our data, how to process the data, how to visualize it, and how to really use it in real life. So this is what we've been working on.
Okay, well, Sean, I'm sure the user community is very excited to get their hands on these data. Sean from EUMETSAT, thank you very much. And now I'm going to hand it back to Chiara.
I will be on late.
Meanwhile, we are less than 30 minutes away from the launch of MTG, and again, I am here amongst friends and family. So I am here with George. Hi, George. Who are you here to support?
I'm here to support my wife, Carolina Vaderwijk.
Perfect. So I understand your wife has been traveling since October, so that must have been quite the switch for you and the kids. What did you do to cope with this?
Well, thank God we live in a modern age. So, I mean, we do have WhatsApp and all the other things. But we decided to incorporate some help with the school. So we sent all the videos and all the pictures that have been released to have them present this at school, which kind of helped to get the help from school, get the energy going. They were very happy and very keen, and it was very nice to see the kids being proud of what their mum was doing. So
Wonderful.
That was very nice to see.
That's really, really nice. Thank you so much, George. And with that, we go back to you, Kelsey.
Well, ladies and gentlemen, in a minute we will go live to Kourou for the launch coverage, and the Ariane 5 rocket is still on the launch pad there with MTG waiting on top. Now let's wrap things up with Peter van den Brambusse from ESA and Johan Grandel from EUMETSAT. Now, I'm just going to ask you guys for some quick statements because time is running out and we do want to watch that launch coverage. They're not going to wait for us. Peter, MTG is new, it's better, and?
It's not alone, because we launched today the first, and in total we will launch 6. And they're not just 6 satellites, they are very reliable satellites, an operational mission. And also we have an FCI and LI instrument, which I think are the best instruments in the world today in their class, and they will remain for a few years. And that was possible thanks to the cooperation of the teams in industry, ESA and EUMETSAT, and also the dedication, the focus and the creativity of the people. And I'm very proud of that, and I thank them all.
Very wonderful.
ESA's role is about to end, and EUMETSAT's role is about to begin. What are you looking forward to, Jochen?
Yeah, well, okay, this is the beginning of the end of the end of the beginning, or which way would I say it? I mean, it really depends on who talks. I mean, for ESA's side, this is kind of coming to the end of their part of the space segment. For us, it's really beginning. I mean, we start to see the data. We do the first year of commissioning, which is really the important part. We see really the first time of it. We have lots of issues, problems certainly going to be there as well. We will solve them, and we'll have the data for the users. It's going to be very exciting. And the users are asking us all the time, when do we get the data? And of course, we can only say that when it's good enough, but it will be roughly a year.
Thank you very much, Jochen from EUMETSAT.
And Peter from ESA, gentlemen, thank you. Now please allow us to give the floor to ESA's Director General, Joseph Aschbacher, who sent us a video message. Afterwards, we will hear from Germany's Federal Minister for Digital and Transport, Volker Wissing, followed by Thomas Dermijn, who's the Belgian State Secretary for Economy and Science.
I'm really sorry for not being with you at this launch of MTG, and you can imagine how much I want to be with you, because this mission, this satellite, was developed partially under my directorship when I was Director of Earth Observation, and of course now with Simonetta taking over and finalizing this wonderful project. But let me take this occasion to really thank the teams, the partners and industry for the fantastic work you have been doing to make this happen. First of all, let me thank EUMETSAT. EUMETSAT is an incredibly strong and good partner of ESA since many decades. And also in MTG, we have worked extremely well together, thanks to your leadership in putting the program together and our help in developing the satellite and making sure it is according to the requirements of EUMETSAT. But let me also thank industry, in particular Thales and OHB, who have been the primes in developing this satellite, to really go through all the difficult phases, and I know there have been many of those, some technical hurdles which we had to solve together. We have managed very well, and I really would like to express my sincere appreciation for being and doing such a wonderful job. But also, let me thank my team. My team in ESA, as previous Director of Earth Observation, but now as Director General of ESA, I'm very happy to say that you have done an incredible job. Paul Blythe, as the Program Manager of MTG, has gone through it. And your team and yourself, I think, have really created a marvel, which is this MTG-I satellite. And you know how much I would like to be with you at this launch. It's very close to my heart, and of course everything will go fine, fingers crossed. But really, I look so much forward to this satellite being in orbit, being launched with Ariane 5, one of the last Ariane 5 rockets, which has been incredibly reliant. And I wish you good luck. MTG, go, MTG, go.
The French writer Marcel Proust once wrote in his novel In Search of Lost Time that the only real voyage of discovery consists not in seeking new landscapes, but in having new eyes. Ladies and gentlemen, today we are looking at the first of a new generation of Earth observation satellites, which will help us get a better and sharper view of our planet Earth than ever before. As a reaction to climate change, satellite data are the key to evidence-based policy making. This is the only way we can reliably assess our baseline situation, respond to extreme weather events at short notice, and evaluate our policies in a transparent manner. Be it in the field of disaster control, air transport safety and security, or marine and coastal management, there are almost no limits to the potential applications of MTG data. At the same time, the statements we can make based on MTG data with regard to these applications will become more and more precise and reliable. Therefore, MTG is undoubtedly a success story of technical and academic progress. However, MTG is also a success story of European cooperation. It is times like these that remind us all painfully of the fact that international cooperation cannot be taken for granted. The successful European cooperation during the development and construction of MTG shows that we can build a better future for all of us by working together towards a common goal and by sharing our knowledge. For Germany and the other member states of ESA, setting up and developing a sovereign European data infrastructure is such a goal. With MTG, we have jointly reached an important milestone and have once more underlined Europe's leading role in the field of meteorology and Earth observation. Let us now jointly look at our planet Earth with new eyes. I say, go MTG, go.
Hello, good evening everyone. I'm very pleased to be with you on behalf of the Belgian federal government. And I'm very glad to be with you at this MTG-I conference, though it's a virtual presentation, because Belgium is a very small country on Earth, but is a big country in space. We are one of the founding members of the European Space Agency since the mid of the 70s. We are also one of the historical countries of EUMETSAT since 1986, and we have continuously invested in our space capabilities, and it's again the case in the last ministerial meeting of the European Space Agency. We have a very broad industrial base in the spatial industry. We have also a very vivid scientific community working on these matters. I would like to congratulate you on this anniversary for the MTG program. For me, it's the sign of a very fruitful collaboration between ESA and EUMETSAT, and we need in the future to multiply these kind of collaboration. It's very important for Europe, it's very important for the collective services that you bring to the European population, and it's the way to go that we see this kind of collaboration in between different agencies. Anyway, Belgium will be and will remain a very important sponsors of MTG, of EUMETSAT, and we wish you a very fruitful evening and we look forward for further collaboration. Thank you very much and good evening.
Ladies and gentlemen, it is now time to go to South America, to Europe's Spaceport in Kourou.
And to follow the final procedures of the launch preparations, the liftoff, and the in-flight phase of Ariane Flight 259 with Meteosat Third Generation on board.
Now, we will be back afterwards with confirmation of these solar array deployments. So in the meantime, please enjoy the live broadcast brought to you by Arianespace.
Thank you very much for now. See you later, and fingers crossed for launch.
And good luck with everything. We'll speak to you later. Well, we have a packed program for you tonight in Kourou. But now let's welcome Raphaël Chevrier, Business Developer Innovation from Arianespace, and Mathieu Chez from Ariane Programs at Ariane Group. Good evening to you both. So happy to see you both. Welcome back to Road to Space.
Good evening, Emma. Good evening.
Mathieu, you will be talking to us essentially about the Ariane rocket, and you, Raphaël, of course, will be helping us understand the finer details of tonight's flight. So to kick off tonight's proceedings, we have put together some images of the different stages of flight VA259. So, Raphael, I would like you to comment on them, please.
Yeah, of course. As Ariane 5 is sitting now on its launch pad in French Guiana, as we can see on the image, what we will see first is the ignition of the main stage, engine Vulcan, for about 7 seconds. I think the video is going to be displayed, before the 2 lateral boosters actually ignite and the rocket soars into the sky.
Here we have the images.
Yeah, so only 2 minutes and 21 seconds after liftoff, the 2 boosters have done their job of providing the main thrust, and they are detached from the launcher. Shortly after that, we separate the fairing, as we have crossed the limits of the atmosphere, and we don't need to protect the satellites from the friction of the air anymore. Once the main stage has put the launcher on an intermediate orbit, it is also detached, and we enter what we call the second propelled phase of the flight with the ignition of the upper stage engine. It powers for about 16 minutes in order to raise speed, altitude, and to reach the transfer orbit, where the satellites are released. At this stage, the whole assembly is going to weight only 2% of the launcher's initial mass. And after some orientation maneuvers, we first separate the upper passengers. So first Galaxy 35 and then Galaxy 36, so one after the other. The little towers that we see on the motion pictures represent a chain of telemetry stations receiving data from Ariane 5 all along the flight path. Then we separate the dual launch structure Silda before releasing the lower passenger MTG-I1. And then, exactly like in a relay race, we pass the baton to the customers, who will perform all the maneuvers necessary to get the satellites into their final geostationary orbit. And this is not really the end of the mission for Arianespace, because we perform what we call a passivation of the upper stage, meaning that the remaining propellant of the tanks is expelled in order to prevent any risk of explosion in space. And once it's done, we can call it a mission terminated, a mission done.
Thank you, Raphael. So in less than 30 minutes, Ariane 5 will lift off from Kourou with all the teams who will be completely focused on the progression of this mission. We will have the privilege of gaining access to the temple of this spaceport, the Jupiter Control Room, the place where the launch operations are managed. And here with us tonight, we can see perhaps up on the screen representatives from the different space companies directly involved with tonight's mission. We have André Hubert-Roussel, CEO of Ariane Group, I trust this is him up on the screen. Yes, I'm right. Hello, Mr. Daniel Nieuwenschandaer, Director of Space Transportation at ESA, who is just on the screen. And of course, Marianne Claire, Director of the Guiana Space Center. There she is, Directrice du CSG. Okay, so today's launch continues Intelsat's Galaxy Fleet refresh plan, which began with Galaxy 30 in 2020 and carries the third pair of satellites launched over the last few years. These assets will provide occasional services to cover North America. We will learn more about these 2 very special passengers on board in the following report. So see you in a couple of minutes on Road to Space. We'll be back afterwards. More entertainment aimed at North America. Galaxy 35 and Galaxy 36 will soon provide high-performance media contribution capabilities and support live event coverage for Intelsat customers.
Our video neighborhoods around the world reach 2 billion viewers. These are 2 billion people who are informed, entertained, educated, and inspired by the content we bring to them on behalf of our customers.
Launched aboard Ariane 5, the 2 geostationary communication satellites are part of Intelsat's Galaxy Fleet refresh plan that started with Galaxy 30, also launched on an Ariane 5 rocket back in 2020. As the newest additions to Intelsat's Galaxy Fleet, Galaxy 35 and 36 will contribute to the most efficient media distribution system in North America. The Galaxy 35 and Galaxy 36 satellites will bring C-band contribution capacity to support high-profile events such as collegiate and professional football, auto racing, baseball, golf, boxing, and professional wrestling.
It really takes a lot of people and a lot of companies to design, build, test, launch, and then operate a satellite. We're very fortunate we have some of the best people in the industry, and everybody contributed to this big success.
Built on Maxar's 1300 class bus, one of the most trusted commercial spacecraft platform and backed by Maxar's 60-plus years in satellite manufacturing, these two new satellites support Intelsat's successful, uninterrupted transition in the C-band spectrum and Maxar's commitment to customer success and improving life on Earth.
Well, in less than 15 minutes, Galaxy 35 and 36, the two satellites designed by Maxar for Intelsat, will launch into space on board Ariane 5. Ariane has been working with Intelsat since the beginning of Ariane right through to Ariane 5. And soon, Ariane 6, a remarkably long-standing partnership, Raphael.
Yeah, I mean, the teams are very used to work together. As a matter of fact, there is one Intelsat operator, I've been told, that is working on this campaign, and he was already there in 1983 on the first launch of an Intelsat satellite on an Ariane. And since then, we have launched on 60 different launchers. Intelsat satellites. So that's one launch every 8 months.
Incredible figure.
And it's not going to be stopped because we have announced the signature of a new launch contract on Ariane 6 to launch 2 Intelsat satellites, 41 and 44.
Well, we will also be bringing you news of Ariane 6 later in the program, but for now, let's stay focused on tonight's mission. Well, we've just been introduced to the two Intelsat passengers, but as you know, they are not the only passengers on board Ariane 5 tonight. Their fellow traveller is, how might I describe him? Well, he is really quite remarkable. Designed in the south of France by Thales Alenia Space, MTG-I1 is the first of 6 new generation satellites designed to revolutionize weather forecasting for EUMETSAT. To find out more about him, let's watch this next report. As the threat of extreme weather events is increasing, accurate weather forecasting and nowcasting is now more important than ever. What if the most complex geostationary system ever launched could help predict storms, save lives, and safeguard goods? This is the mission of MTG-I1 that will take off from Europe's Spaceport today on Ariane 5. A highly anticipated launch for the very first Meteosat Third Generation constellation satellite operated by the European operator EUMETSAT. It is developed by the European Space Agency with Thales Alenia Space and more than 100 entities from all over Europe. A true symbol of team effort and dedication, of cutting-edge technology and innovation, this heralds a brand new era for weather forecasting.
This new generation is important, first of all, to guarantee continuity of data for a long period of time, to support users, not only public users, but everybody. Everybody means every citizen today, with more accurate information, with more spatial resolution, with more timely information for the relevance of the daily use of everybody.
Meteosat is part of our DNA at Thales Alenia Space. We have been the trusted prime contractor for all the Meteosat satellites since the 70s. Meteosat first, second generation, and now third generation. Through Meteosat, Europe supplies the best meteorological satellites in the world, thanks to ESA and EUMETSAT, and plays a major role in world weather forecast. Our teams at Thales Alenia Space are extremely proud to be part of this success story alongside with OHB and all other contributors.
These third-generation weather satellites will revolutionize nowcasting of weather in Europe and Africa by helping storm prediction and enhance weather forecasts.
MTG-I, and in due course the full MTG-I programme, will be critically important for supporting nowcasting. Nowcasting is the forecasting over a short period of time, up to 6 hours. which is most important for intense localized events, which in reality are very difficult to forecast on longer timescales.
The major thing that the MTG does is to do that. It picks up major storms in their infancy, so we can actually take the necessary steps to ensure safety of life, prepare for the deluge that might happen.
The social and economic benefits of accurate forecasts are huge, and this is largely thanks to satellites.
Weather, and particularly severe weather events, take a huge toll on European society. In fact, in a recent survey of its members, the World Economic Forum identified that the key risks that countries see themselves as facing over the next 10 years are severe weather events and the failure to respond adequately to climate change.
ESA and EUMETSAT have been working together for over 4 decades to maintain Europe as a leader in satellite meteorology. MTG-I1 will shortly be joined by 2 other EUMETSAT satellites, MTG-S1 and MTG-I2. Together, they will provide essential weather and climate data for the next 2 decades to come. We will come back to this highly sophisticated satellite later on in the program. In the meantime, I would like to focus on our launcher, Ariane 5. Because tonight, Ariane 5 will make its 3rd flight of the year, and also, guys, one of its last. The European heavy launcher made her first ever flight over 25 years ago, so this means Ariane has been in operation for, what, a quarter of a century, Mathieu? How would you sum up this heavy launcher, and for you, what memories will she leave behind? I say she.
No, it's impossible to summarize what is Ariane 5, but you have to remember it's a European success story made possible by 12 contributing countries with institutions, agencies, and of course, industry with unique competencies all over Europe. And if you look just at the performances, tonight we're about to launch 11 tons towards a very energetic orbit since we reach a velocity that's above 33,000 km per hour. So just one memory, this launcher is the one that allowed the first images we got from the James Webb telescope, for instance.
Can I ask you also, what can you tell us about her evolution? She's obviously evolved a lot since her first mission.
Yes, that's really in the DNA of Ariane 5 and actually the Ariane family, to be evolving in an incremental way. If you compare actually the launcher we have tonight on the launch pad with the first version of Ariane 5, we almost gained 5 tons of performance. So it went through the introduction of new engines with the introduction of Vulcan 2 evolutions on the upper stage with the cryotechnic upper stage, but also storable propellant at one point that allowed Galileo or ATV missions. So yes, that's really always a principle to push the limits as much as possible to be able to serve any mission.
We're now 30 seconds away from the DDO announcing the synchronized sequence. Yeah. The DDO is obviously the Range Operations Director. He will be announcing the synchronized sequence, and I would just like to ask you before this, you two, if you can explain what it is.
It's the last crucial step. It's a succession of operations aimed at giving more and more autonomy to the launcher. And for this, everything that you see on the board needs to remain green. The space base, the launch vehicle.
Attention pour la séquence finale lanceur.
So the DDO is about to announce.
Top, H0-7 minutes.
Yeah, so you see that everything is green, so the sequence has started.
Yes,
the countdown has commenced.
Yes, this is really the ideal situation in which you want to be. Everything is green. So what does it mean to give autonomy to the launcher? So we'll do the final steps to put it exactly in a flight configuration, which means the final loading of the tanks, the topping, as we say, also the pressurization of the tanks, and a few minutes, 3 minutes before launch, we'll give the launcher the exact date, time of the launch.
And as we want that, of course, 100% of all the parameters remain green, if one turns red during this synchronized sequence, then the clock will be set back to 7 minutes before the launch. Of course, we don't take any risk. We don't leave anything by chance.
What kind of problem could stop this synchronized sequence?
Well, I mean, like I said, like all the parameters that you see could turn red. For example, if there is one telemetry station that is used to follow the launcher during the flight, if it has an issue, then we need to fix it before actually launching, of course. We are checking all the safety means, make sure that it's in place in order to actually authorize the launch. Need to check that there is no issue on the satellites, of course, on the launcher, on the space base. So right now, everything is red, so we should be able to continue the countdown.
Well, before that, we're obviously watching Road to Space, and now we have some images from the events of the launch campaign in front of us, which are coming up on the screen at the moment. If you, Raphael or Mathieu, you could comment on them, please, because we're waiting.
The campaign started a month ago when the stages were shipped from our facilities from our group in Les Mureaux and Bremen towards Kourou. There you see the main cryogenic space that's getting out of its container, and then the boosters, each one of them holding 240 tons of solid propellant. And then the upper stage has been mated on top, and once this assembly is ready, you can move to another building so that the launcher meets the satellites.
So talking about the satellites, the MTG-I1 satellite arrived in French Guiana last October by boat. Also, it was transferred to preparation facilities where actually many operations are done. Satellites is removed from its container. It is integrated on its adapter. It is fueled. And like you see, these are very careful operations. On the other hand, the Galaxy 35 and Galaxy 36 arrived in late October, November, respectively, by plane in Cayenne. They were transferred in a special container by road to the Guiana Space Center in Kourou. Both satellites are also removed from the containers in clean rooms. They are carefully inspected. You saw it like turning on itself. You can see on the images the size of the operators. That's quite impressive. You can see the size of the satellites next to it. It's always a bit amazing.
We're talking about spacecrafts that weight 3 tons, 3.6 tons. It's massive.
And so here, they are like checking that everything is perfectly right. And then the satellites are transferred in the final assembly building where they are meeting the launcher finally for the first time.
Yes, so we can actually, you can see Galaxy G36 that's set on the dual launch structure, the steel DAS and the 35 on top, and finally the fairing is actually installed on this tiered cake. You know, it's like a wedding cake where you put everything together, and MTG in parallel is assembled directly on top of the upper stage.
And then only then the whole SILDA, Galaxy and fairing assembly is positioned on top of MTG, right as you see in the images. And I think, you can see the special drawing, the piece of art on the fairing.
Oh, that's right, I can see it.
It's small, but it's there.
And the final step that you see is when we roll out the launch table and get to the launch pad.
Guys, we are 2 minutes and 35 seconds away. All this hard work will shortly come to fruition when in a few seconds Ariane 5 will take off on one of its last missions. The 3 passengers on Ariane 5 are a bit like us, impatiently looking forward to this journey into space. They are, of course, the 467th to 469th satellites to take off on board on the Ariane launcher. Well, I imagine the VIPs are now firmly installed on the balcony, guys, with the best view in the house, not only seconds away from liftoff. What can we expect tonight? The last time she took to the skies, I remember it was quite a show.
I mean, it's quite clear, the sky here, so I hope we'll have sort of the same spectacle. We might see the booster separation with our eyes. Maybe like last time we saw the fairing separation. I'm not sure we're going to see it in daylight. It really depends on the clouds and the angle of the camera, but I have like high hopes for tonight.
I feel that we might be extremely lucky to see all of this.
They're all running out onto the balcony.
And, there are some clouds, but from time to time, between 2 clouds, you can see actually these boosters getting separated, and I really hope that we'll get to see these 3 dots in the sky.
Well, Tamara Tezele, the Range Operations Director, is about to announce that we have hit the 1-minute mark before liftoff. Everything is set to go, guys. Best wishes to all the team, so let's sit back and enjoy the show, as they say.
À tous de DDO, attention pour moins 1 minute. Top à 0 moins 1 minute. tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des EAP décollage. La propulsion est nominale.
And we are off. How wonderful to see the mighty Ariane roaring across that equatorial sky. Definitely a launch to savor. We are now over 1 minute into the flight as she powers her way into space, heading east out over the Atlantic Ocean. Raphael, Mathieu, a reaction?
It's hard to get tired of it, right? I mean,
it's amazing.
Look at this.
Yeah. I might be an engineer, but still I have emotions when I see that. No, that's amazing.
Like a ball of fire thrusting itself into
and we are extremely lucky because we can clearly see the rocket like blasting its way towards
Raphael,
space.
what do you have to tell us?
Well, I mean, everything is going to happen quite quickly now. You'll have in a few seconds the booster separations.
That's the first thing we have to look out for.
Yeah, they will have provided 90% of the overall thrust in order to literally escape the gravity pull of the Earth.
And with the clear sky, we'll see them well.
I hope so. I think we will. And then you will have the separation of the fairing when we have crossed the limits of the atmosphere. It's protected the satellite from the friction of the air, but also from the noise generated at the booster's ignition. And then we will have the separation of the main cryogenic stage. And here you can see the booster separation.
Yeah, we see it so clearly.
We see it
so it's confirmed
clearly.
Visually and also in our...
By the DDO.
By the DDO.
Brilliant.
And okay, so the sky is perfectly clear, so it's perfect conditions to
So, Mathieu, without these two boosters, the launcher is obviously now a lot lighter. So, than it was at takeoff. Its load has been lightened by how many tons, and why is this necessary, even essential? Does lighter mean faster?
Yeah, it was 775 tons on the launch pad. Now it's about 156 tons because we got rid of this empty boosters. Imagine that we managed to get rid of about 500 tons of propellant in about 2 minutes and 20 seconds. But this is the amount of energy that you need to go to space. And this is a principle. You get rid of any useless mass to provide maximum acceleration to the satellites. And now we've got fairing separation.
The fairing separation.
And we actually can see it. So we have, again, visually the confirmation and also by the DDO.
That's brilliant news.
We can actually see the two halves of the fairing getting separated. That's magical.
Those images are incredible.
And this is the last time, by the way, we see the piece of art that was on the fairing.
Bye-bye.
Yeah.
Well, thank you, Raphael. As you can see on the screen, computers are generating now perhaps CGI images for us to see what's happening. It will be coming up in a minute. We have 5 minutes, not now, because obviously the skies are so clear, we're seeing everything. We have 5 minutes now before our next milestone. So let's focus on our launcher, Ariane 5. Mathieu, I'm turning to you. Could we come back to the particularities of this heavy launcher? It is the reference in space transportation.
Yes. Internally, we call it the legend.
The legend.
the living
legend.
The living legend. I mean, for most of the engineers of my generation, somehow we grew up with this launcher, and personally, it directly inspired my career and my aspiration to go to space. But think about some of the missions it allowed. One in particular, in 2004, the launch of Rosetta, and that's That's all. For the first time, we managed to land
La
a probe
propulsion
on a
nominale, le
comet.
pilotage
So
est
that's
calme.
really what it's able to do. Or we service the space station 5 times with the automated transfer vehicle. Again, I mean, Ariane is almost a member of any of our European families. And actually, Raphaël spent Christmas with Ariane, right?
Yeah, it was last year, yes. I was lucky enough to be in French Guiana, and that was obviously a very, very emotional launch. It's very hard to describe the tension it was before the launch. Hard to describe also the tension released after we got the confirmation of the separation of the satellite, and we witnessed the deployment of the solar panel.
That must have been incredible.
In real time. It was really amazing. And it's also, I have to say, very hard to describe the admiration that I have for my colleagues, Ariane Space, Ariane Group, and all the teams that were involved in this launch that made history for Ariane 5, I think.
Well, of course, tonight, Ariane 5 has 3 very special passengers on board. MTG-I1, the first imaging satellite of the Meteosat Third Generation program, and of course Galaxy 35 and 36, 2 communication satellites built by Maxar in California. Mathieu, what is the maximum number of satellites that Ariane 5 can carry? I've seen 1, 2...
Yes, a typical mission for Ariane 5 would be what we call a dual launch. And actually, the SILDA means dual launch system in French. But tonight we have 3 payloads because we're really capable of adapting this launcher to any needs. If you remember, too, we were able to deploy 4 Galileo satellites when necessary on Ariane 5. So that's really the philosophy I described, adapting the launcher to the customer's needs.
And with Ariane 6, we will have even more flexibility and versatility because there are some dedicated structures that are being developed under the fairing, for example, in order to accommodate small satellites. It's called the multi-launch service. We have dedicated carrying structures to deploy many satellites of a single constellation at a time in a single flight. We gain lots of flexibility with Ariane 6.
A lot of things to come, and we're looking forward to that. Well, thanks for all those interesting souvenirs and fun facts. The next important step will be the cutoff of the main core stage, the extinction and the ignition of the upper stage.
Yeah, the ignition of the upper stage is absolutely key for the rest of the mission, and it's always a bit tricky to actually ignite liquid stage in the emptiness of space.
I imagine.
Yeah.
Yes, we're going to go through a series of events, and as you can see, it's really going really fast. First, of course, the cutting off of the main stage that's propelled by the Vulcan 2.2 engine. 2.1 is for Ariane 6, sorry.
La propulsion est nominale, le pilotage est calme.
Yeah, and everything's nominal. As a separation of the upper stage
Acquisition
from
de
the
la
stage.
télémesure par la station natale au Brésil.
Yes, and then the ignition of the stage. And as you said, it's technically it's very challenging. It's not like igniting a cryotechnic stage on the ground. You have to do it in space with very, very particular thermal conditions. And of course, you're in 0G, so your propellant might go everywhere. Yeah.
Well, thank you, Mathieu. Now we're waiting for Tamara Tezelé, the Range Operations Director, to confirm the next important steps of the mission. So we have...
La propulsion est nominale.
So that's an important information. Everything is going nominal.
Well, that
the trajectory
is very
nominal.
important.
The launcher is behaving like it was planned.
Behaving well.
So it's very important.
And I cannot believe that the sky was so clear that we could see.
I know, we still haven't kind of quite got over that. That was wonderful. Well, we are now looking forward to the cryogenic main core stage cutoff. Yep. And then there is a series of we'll lose the signal at Galileo, the cryogenic main core stage separation.
Yes.
Do you have any news in your earpiece?
We're waiting for the
3 images are showing.
Séparation EPC.
Okay.
So it's confirmed. The separation of the main stage is confirmed, and we are waiting for
Allumage ESC.
Wow.
what was just said, the ignition of the upper stage. So that's a very important step.
We're halfway there.
Yeah,
so all going according to the plan.
So far, so good. All is going to plan. Well, I'm very happy about that. Well, Ariane is heading for a geostationary orbit 36,000 kilometers from Earth. Is this a fairly standard mission for you? What is at stake tonight?
We are used to launch in geostationary orbit, but every mission is very unique. It's The satellites are different, the trajectory is slightly different, the performance of the launcher is different. And it's years of work for all the team, for the satellite team, for the manufacturing of the satellite, the launch contract signature, typically 2 years before the launch, and then all the mission preparation, especially on the launcher side.
Yes,
La propulsion est nominale, le pilotage est calme.
Yeah, it's only a 40-minute launch, but of course it took years and months of preparation upstream, and you only see the accomplishment and the result of a lot of things that were manufactured, integrated perfectly.
Well, congratulations to all your teams. Thanks. We will continue to follow this mission very closely until the separation, which we're all waiting for, with bated breath, of our 3 satellites. Galaxy 35, of course, will be the first of our passengers to separate from the launcher in roughly 20 minutes from now, followed closely by Galaxy 36. Then it will be the turn of MTG-I1's turn. Well, guys, we will be living these exciting moments. I will be living these exciting moments with you, both live. But for the moment, let's look to the future, and a not-so-distant one. We've already looked back at the career of Ariane 5, but what is the latest news on the much-anticipated launcher Ariane 6? I'm sure you're all, like me, dying to hear the latest news. And so I'm turning to Mathieu, who will give us all the answers with these new images.
Yeah, it's been an exciting year on Ariane 6 for the ESA, Ariane Space, Ariane Group and CNES teams with the preparation of what we call the combined test. What you see there are a fully representative version of the launcher with the upper stage and the lower stage that were integrated in Kourou, and you can see that now the operations are performed horizontally, and you can see how easy it is almost to join these two launchers. In parallel, we prepared also fully representative mock-ups of the boosters of Ariane 6 that you can see there. By the way, one of them is fully filled with sugar.
Sugar?
Yes. That's,
you're kidding me.
Yeah, we will not ignite it, otherwise. So once the two stages are integrated together, they've been transferred horizontally, and you can see that at the end of the road, our road to space on Ariane 6, you've got this new mobile gantry that will be on top of the launch pad of Ariane 6. We now do the integration of the launcher directly on the launch pad. Operationally, it's a really game changer for us. It will ease everything. And we only go vertical once we are on the launch pad. So you can see this very first time we rehearsed this operation, and everything went very smoothly, nominally, as we say.
That's good to know.
You hear a lot about nominal. And now we're ready to perform combined tests, which is really when the launcher meets the launch pad. But in parallel, we've got also a very, very important test campaign. Now we are in DLR facilities in Germany, in Lampolshausen. We're ignited for the first time a fully representative upper stage with a Vinci engine for 45 seconds. And we've got more tests to be performed. And finally, something's missing on top of this launcher.
What is missing?
You must have recognized it, is our brand new fairing, 20 meters high. Yes.
Okay.
And you see the last rehearsal was really to check that we can hoist correctly this fairing on top, and there again, everything went very smoothly. And yes, I'm always very impressed with this mobile gantry. It's about the weight of the Eiffel Tower, except that you can roll it back when you need to launch. But,
all I know is we are all waiting impatiently for its maiden, its inaugural flight. Sorry.
And look at this final image that we managed to get at the end of this year. Yes.
Well. Yeah. As Ariane 5 picks up speed to climb higher and higher, it continues its flight path with 3 very special satellites on board, including MTG-I1, as you know, the third generation Meteosat satellite built by Thales Alenia Space, with monitor climate and weather changes in Europe and Africa. Now, to show the strategic importance for the African people of such a launch, Ariane 5 has taken off, as we mentioned earlier, decorated on its head, on its fairing, a unique work of art. That is why the flight tonight, VA259, has been baptized state-of-the-art. This artwork is part of ASAP, the African Space Art Project. And to find out more, let's watch this next project. Report. Under Ariane 5's fairing is MTG-I1, EUMETSAT's new weather satellite. On the other side of the launcher's cone shape, memory of today, memory of the future. This is in fact an artwork created by 3 African artists. It is part of the African Space Art Project, ASAP. This painting symbolizes the link between the European operator EUMETSAT and the African continent.
Through this artwork, the artists have demonstrated a link between Africa, space, and climate change. These 3 things are at the heart of what EUMETSAT is about. I'm incredibly proud that EUMETSAT has been a part of this project.
The collaboration between these 3 artists, Geraldine Taubé, Michel Ekaba and John David Encott, is also a tool to raise people's awareness about Africa's climate challenges.
C'est quelque part la signature artistique, symbolique, historique du continent africain qui va créer une relation tout à fait particulière avec l'espace parce qu'il a besoin d'observer de l'espace le changement climatique qui l'impacte de façon très très forte alors que c'est le continent qui aujourd'hui émet le moins de CO2 dans le monde entier.
Pour nous, l'art était une manière de faire passer tous ces messages en même temps. À la fois, ces satellites vont répondre à des besoins vitaux et à la fois, c'est aussi un signe d'une innovation technologique et d'une aspiration de l'Afrique d'avoir un vrai rôle dans tout ce qui est spatial.
Selected by a jury including representatives of EUMETSAT, Ariane and the African Union, the collaborative artwork carries a message of hope, harmony and sustainability.
Une chose que je retiens quand même lors de ce travail, l'impossibilité a permis le possible. D'où justement aussi le titre de cette œuvre, Mémoire d'aujourd'hui, Mémoire du futur. On a l'impression que nos différences ne nous permettent pas réellement de faire des choses. Mais justement, ce sont ces différences qui font la force de ce que nous sommes aujourd'hui et qui apportent un plus dans le développement du monde dont nous rêvons.
A world where space is used in a sustainable way to support the Earth and prepare for tomorrow. What an interesting report. Well, Raphael, is this the first time a work of art adorns the fairing of the launcher?
Well, usually you have company's logo on the fairing, which is good, but now we have an artistic dimension to it, to the launch. The project dates back to 2018, and I had the chance, actually, the team had the chance to see the piece of art 3 meters long when it was exposed in Ariane Space's offices before it got installed on the fairing. But I think this is not the first time that the Ariane launcher is involved in artistic projects.
Yes, no, but because this launcher is not inspiring engineers like me only, but also artists. And we've set up very, very interesting collaborations with some of the artists. For instance, I'm wearing an Avenir hoodie, which is actually from the French singer Orelsan.
I
have the T-shirt.
Yeah, it's directly...
I look forward to my T-shirt and my sweatshirt afterwards.
Yeah, we'll talk about this later.
Okay, we'll talk about it later.
But it's directly inspired by what we do, and also for the 40th anniversary of Ariane, we got an entire album composed by a musician.
Wow.
Very inspiring music.
That's brilliant.
Yep.
Well, let's get back to our mission at hand, guys. In about 15 minutes, as you know, MTG-I1 will separate from our launcher. This exceptional satellite built by Thales Alenia Space for Maxar will eventually revolutionize weather forecasting. It will be placed in geostationary orbit. But, Raphael, I have a question. I thought that geostationary orbit is mainly populated with telecommunication satellites.
No, it's true that with Ariane 5 we are used to send telecommunication satellites on the geostationary orbit, dedicated to broadcast, broadband connectivity, and many more applications to connect each other. It is indeed not every day that we launch an Earth observation / scientific satellite on this such distant orbit. The asset of the geostationary orbit is that it covers a large surface of the Earth because it's like 36,000 kilometers from the Earth. So you have like a global view, so you can measure like in a global scale for MTG, lots of things happening in the atmosphere. And as a matter of fact, you only need 3 satellites to cover the whole surface of the Earth in this geostationary art. And we will launch with Ariane 6 2 more MTG satellites, new generation of MTG satellites, the S1 and the I2. This is going to be with Ariane 6.
Well, Before we go on, in order to be able to properly exploit the numerous data from the exceptional satellite, Meteosat had to train its users, and there are many of them. More details in this next report, ESTEC, EUMETSAT. MTG-I1 will soon start a new mission, revolutionizing nowcasting of high-impact weather in Europe and Africa. The first data to be collected will considerably improve our daily life. EUMETSAT carefully trained and prepared future users to achieve these results.
We'll have 50 times more data coming from the new satellite compared to what we have now. So we need to handle all this data and make it accessible.
EUMETSAT is playing a crucial role to ensure that the data from MTG satellites will help to protect people and property as fast and as efficiently as possible.
Based on the new data, we'll be able to issue more precise warnings of severe weather. That saves lives, that saves journey time on your motorway, that saves transport costs, that saves airport costs. It also saves costs related to flooding, for example. So we'll be able to save lives and property based on better forecasts at the very short term, which means in the next hour, in the next 2 hours, in the next 6 hours.
With its brand new technology, MTG satellites will provide key data for the years to come.
Some of the data has new information in it, which we don't have from other geostationary orbits over Europe, and that's really very exciting. We are not having that from anywhere else.
It's European satellites. It is better satellites than we had before. They have a higher resolution, which means that we can see more details in the images. This is all very exciting because it brings a lot of potential, a lot of new possibilities.
This data will also be an important source of information for the aviation field, where nowcasting is essential.
If the visibility goes very low or the cloud base gets very low, they need to do different kind of procedures. They cannot have so many planes moving on the airport, and they kind of need to get ready for that one. And then the nowcasting comes in, and we try to warn their airfields about those things.
After years of preparation, MTG-I1 is now on its way to geostationary orbit to help us all to better anticipate tomorrow's weather. MTG-I1 is on its way effectively to destination at 36,000 kilometers from Earth. It will be put into orbit in a little over 10 minutes now. But before that, our launch has to complete a number of important steps. Raphael.
I mean, the first one is the cutoff of the upper stage engine to prepare the first satellite separation, Galaxy 35. It is very important to do it on time because it's really driving the satellite injection accuracy, and it has an impact on the rest of the satellite lifetime in space.
Yeah, 1 second too early or 1 second too late, you're not on the same orbit.
I imagine.
Yeah. And I mean, Ariane 5 had a reputation for being very precise because last year, when we injected very precisely the James Webb Space Telescope, it allowed the telescope to double its life expectancy in space because it didn't have to use as much as propellant to reach the final orbit. So from 5 years to 10 years of operations, which is quite convenient.
Well, before the separation of the first satellite, I would really like to have another look at the highlights of the liftoff that we just watched and experienced. If one of you could comment on the images, which should be coming up, the replay of the launch tonight, which was quite fantastic.
I mean, we will comment, but we will also watch it again ourselves because it was very, very impressive.
Very fast. You know, the first event is really we separate these cryo arms that are that are fitting the upper stage. Liquid oxygen, liquid hydrogen. You ignite the Vulcan engine, and once everything's ready, you can ignite the solid propellant boosters, and it's liftoff.
And we need to check that the Vulcan engine is working.
Yes, of course.
Once the boosters are ignited, there is no turning back.
Yes. That's why it's so tricky when we ignite.
It was such a clear sky.
That's what I told you. It's maybe one of the most beautiful launches.
Really, it's one of the most beautiful you've ever seen.
I've attended so far because the fact that we managed to see the fairing separation so clearly is quite amazing.
Yes.
What a show.
Well, in a moment, Ariane 5 will acquire the signal from Malindi in Kenya, or Kenya, depending from where you come from. This is also the signal for the much-awaited countdown to the separation of the first Galaxy 35 satellite. is it not, Raphael?
Yeah. So there are lots of concentration. Right now we are like raising altitude quite drastically. So we are at a speed of about 9 kilometers per second.
Yes.
So it's quite fast.
Good.
We are flying over Africa right now. And so lots of concentration before the last steps. Because like I said, it's a combination of years of work from all the teams.
Yeah, but imagine that in less than 30 minutes, we managed to fly over the Atlantic Ocean and now over Africa. We're really standing on the east coast of Africa.
That is just quite incredible.
Yeah, but that tells a lot about the orders of magnitude that we're dealing with Ariane. I told you the velocity we'll reach is higher than 33,000 kilometers per hour.
Tous les paramètres à bord sont normaux.
Was it easy assembling these 3 satellites under the same fairing for this flight?
Well, I mean, so it was really a meeting of 2 different worlds with telecommunication satellite on one hand and Earth observation / scientific satellite on the other hand. So they have different constraints, and especially on the cleanliness aspects. So we had to be very careful in actually preparing the satellites in the clean rooms and during the encapsulation under the fairing, because you know that one single speck of dust, especially for optical elements, could alter the functioning of the satellites in space.
I think
Extinction ESC.
Yes, we were waiting for this
Tamara
confirmation.
says what she just told us.
Yes, that's the upper stage has been cut off. It means that we've reached our final orbit. So now we're entering another phase.
Are we in the ballistic phase?
The space ballet.
Space ballet. Yeah. I love that.
Yeah, the upper stage is like performing slight orientation maneuvers to separate the first satellite in a specific direction. But we'll see also different maneuvers to be realized in between each separations in order to make sure that there is a right distancing between the satellites in order to prevent any collision, of course.
Well, in 1 minute, of course, there will be the separation of the satellite. G35, thank you, Raphael. We're all waiting eagerly en route to space for this separation. This C-band telecommunications satellite was, of course, built by Maxar for Intelsat. Until then, what are the final important stages that we should be all looking out for?
Well, I mean, we will witness the separation of Galaxy 35, quickly followed by the separation of Galaxy 36. Then we'll have the separation of the dual launch structure, the SILDA, which is the black box right under it. And then we don't see it on the image, on the 3D image, but there is the MTG-I1 that is going to be separated in the final stage. And then the mission is not over for Ariane Space, because we perform passivation of the upper stage, and then it's going to be the end of the mission.
And separation should be right now for Galaxy 35. We're waiting for the confirmation.
Séparation G35.
Okay, so it's half a relief for the customer now.
Confirmed. Happy faces, thumbs up.
You see happy faces,
smiling.
but also concentration, because it's definitely not over.
Yeah.
Now let's head to the fishbowl, where we should be able to see, well, I don't know who he is, but Valérie Boucher. She is Intelsat project manager at Ariane Espace, and the person who coordinated all the internal activities to ensure that the launch went smoothly. It must be such a relief for her when I wouldn't even want to be in her place. But this is, of course, not the end of the mission, is it, guys?
No, it's not, because we said, there are many separations to come. It's also only for the customer the start of the journey, because they have to check that the satellite is doing perfectly, and also to bring the satellite from 1,000 kilometers from the surface of the Earth to 36,000 kilometers. So the journey.
So this here we have Valérie Boucher, Intelsat project manager, and of course before we had Tamara Tesley, who is the Rangers, the DDO, the Rangers Operation Director. Good evening, Valérie Boucher, and congratulations. Galaxy 36 is just about to be separated from Ariane 5, joining its brother Galaxy 35. Raphael, the first 4 satellites of the Galaxy constellation built by Maxar for Intelsat are not positioned in the same orbits. Why is this?
What I mean, they are quite close to each other. They're all positioned on the geostationary orbit, and they're all facing the North American area, which is like a quite big one. So in order to cover everything, you need several satellites to be placed like on this geostationary orbit in order to provide services also for remote areas. We know that in the US there are lots of deserts, mountains, so satellites are key assets to be complementary to terrestrial solutions.
Well, it's time to take a look at what's going on some 600 kilometers now above our heads. What is the status of Ariane 5? Raphael, I think we're waiting for the separation.
Yeah, and you see that we are still raising altitude. We went from 940 kilometers to 1,500 kilometers in only 3 minutes. And we are now about to witness the separation of the second upper stage passenger, Galaxy 36.
G36.
Yeah, in about 30 seconds. Just to give you also another order of magnitude, keep in mind that the International Space Station orbits around the Earth at only 450 or 400 kilometers. So we're way above it.
And before each flight, we make sure that we don't collide with the ISS, which is very important.
Okay.
That's part of the calculation.
Nothing is left to change.
Well, of course, we have our DDO, the Range Director's Operation, Tamara Tesley, up on the screen, who is about to announce any minute. 4 seconds.
Séparation G36.
So we have, so now we see happy faces.
Happy faces again.
For the upper passenger.
And I like the way they do it. You know, it's one sub up for the first satellite and two thumbs up for the second. Yes,
and then 3. Yeah.
Well,
very
that
important
is just
step,
fantastic news.
But this is not over because we still have another passenger to
What is the next? I'm getting very nervous.
Well, we'll see the SILDA, the dual launch structure that is going to be separated. It's also quite tricky.
That's very, very tricky. So you have to separate the structure from the upper stage, and we technically call it an espresso capsule because of its.
It looks like it.
It looks like an espresso capsule. What else?
George, stop it.
Yes, but actually you have to make sure that you're able to separate it very smoothly. It's pushed by a set of springs, and everything is computed before so that it's correctly balanced. Because any unbalance could harm the satellite that's right below the MTG satellite that's right below this structure. So that's very, very.
And when it's on the ground, it has to support also quite a large mass of the upper passenger.
Yeah, you're
it's
right.
Like 6.3 tons of the two Galaxy. So yeah, it has
and it's a very light structure that has to withstand this impressive mass that it has on top.
Well, now in 10 seconds, the SILDA should be.
And should be separated, and we'll wait for this confirmation that it occurred.
We're waiting for the DDO.
And you can really see on the animation there.
Séparation SILDA.
All right. So confirmation that the SILDA has been successfully separated, and you can see that we are still gaining lots of altitude in 2 minutes. We've gained we have now come close to about 2,000 kilometers of altitude.
My question is there going to be a SILDA on Ariane 6?
Yes.
That's what all my space friend geeks want to know.
Yes, we will still need to perform some dual launches or triple launches as we have today. But we have a new dual launch structure, a new DLS, that will be actually larger and higher. So now we can really accommodate bigger satellites on top and below the DLS.
It helps us to propose many different...
Can I just interrupt you? We have now Sébastien Lemay in the fishbowl. He is EUMETSAT's Program Director for Ariane Espace. Good evening. Sorry, I interrupted you.
No, I was saying that we have lots of configuration that we can imagine under the Ariane 6 fairing. This is probably also why we have been so successful in selling Ariane 6 so far, because we sold 28 Ariane 6 already, including 18 for famous constellation. So we are really looking for the first flight of Ariane 6.
I got the message, Raphael.
With only a few seconds to go before the separation of MTG-I1, everyone must be holding their breath now. I'd like to remind you that MTG-1 is the first of 6 satellites dedicated to weather forecasting. We are now waiting for the DDO, Tamara Tesley.
Séparation MTG-I1.
Brilliant. Yes. I want to applaud with them. Brilliant. They must be so happy.
3 thumbs up.
Now you can see the happy faces.
Everyone that we talked about earlier, they are all there. I mean, how wonderful for them. This must be so satisfying after months, years.
Yeah.
What teamwork.
No, again, it's years and years of work.
Years and
also,
years.
I'm sorry, I have to say that it's only the beginning of the journey for the customer, because they have to take...
It's an exciting one.
They take the lead now from their mission control center, and they will perform maneuvers, in-orbit checks in order to get their satellite into their final geostationary orbit.
They are so happy. I'm happy for them.
Look at this.
This is just marvelous.
Yeah, now we need to wait for them to make contact with their spacecraft and monitor the entire health status of each one of these spacecraft.
And for the upper stage, we still need to make the passivation, so release the remaining of the propellant in order to prevent any risk of explosion in space. So there are still some maneuvers to be performed on our side in order to call it a mission success.
But we're obviously now in the fishbowl in the Jupiter control room. Stéphane is going to confirm this the successful mission, this mission completed. But can you talk to us about some of the images coming up while we wait for Stéphane?
Well, no, I mean, everybody is very happy. Maybe I can add that...
Okay, what kind of anecdote can you give us? You've been there, you know what it's like.
I've been there once with customers that were visiting Kourou for the first time. So we were actually attending a launch for 2 other customers. But I can tell you that when you're there, you're really living the situation, and we were in the same boat. Everyone, and the tension there is amazing. And I can really tell you that time doesn't flow at the same pace.
So last Christmas, during the launch of the James Webb Space Telescope, people were wearing hats. Christmas hats.
Christmas hats.
Yeah.
Well, it's not Christmas yet. Stéphane Israel, the CEO of Ariane Espace, will be with us in 2 seconds. I think he's been mic'd. Oh, Stéphane, welcome back, and congratulations to all of your teams.
Yes, I think tonight it's a wonderful success for Ariane and all the Ariane family, Ariane Group, our prime contractor, CNES, which is responsible for the design authority, Ariane Space Team for sure, and for sure a success for our customers and our satellite manufacturers partners. So it's a very nice end of afternoon here in the Jupiter.
Well, you all look thrilled. I'm so happy for you, and we're very happy here in the studio. So what's next here in Kourou for tonight and for the days to come before the end of the year, Stéphane? Can you give us a little idea?
So, yes, in a few minutes we are going to leave the floor to our customers and partners. We have also 2 French ministers with us tonight, and they are going to speak at the end of this broadcast emission. And in the Guiana Space Center, we will be back in 1 week on December the 20th for our last launch of the year with Vega for a very important customer and very important satellites, Airbus, 2 Pléiades Neo. It will be in just 1 week.
Well, thank you, Stéphane, so much. Enjoy, and congratulations again to all of you and your teams. Thank you, Stéphane.
Thank you. Thank you.
Stay with us, everyone, because we are now going to pass the microphone over to Grégory Gavrois, Chief Brand and Communications Officer at Ariane Espace. He will be interviewing 3 important officials from EUMETSAT, ESA, and Thales Alenia Space. There is Phil Evans, Director General of EUMETSAT, Simonetta Kelly, Director of Earth Observations at ESA, at ESA, and Hervé Deret, CEO from Thales Alenia Space. Dear Gregory, are you there? He must be getting mic'd up.
Yes, Emma.
I can hear you. You're with us.
I'm here along with our, not only official, I would say heroes of the day, along with their teams. I'm here with Phil Evans, indeed. Phil, what does this important satellite represent to you tonight?
Well, right at this moment, a very great many things, but in particular, a demonstration of what European collaboration can really achieve. A demonstration of European excellence in space. For EUMETSAT, a critical moment, but more importantly, a critical moment for our member weather services and the communities and industries who will be better protected because of it. And finally, the start of some very hard work for us. Over the next 9 to 12 months, we'll be commissioning the satellite ready for operational status.
Thank you. Thank you very much, Phil. Simonetta, this program, MTG, and not only the satellite of the night, represents a lot to ESA. You told me earlier today that there are two important words to you in this program, innovation and cooperation, right?
Yes, innovation, because we start the next step of meteorology forecast together with EUMETSAT, with very advanced instruments on board, with higher volumes of data, higher resolution, and certainly faster and better weather prediction for extreme weather events. It represents collaboration among member states of ESA, of EUMETSAT, and particularly a good model of cooperation between EUMETSAT and ESA the last 40 years and the next 20 years, but also good work with industry, the European ones, Thales Alenia Space, that were the prime of this project, but also OHB, also Leonardo, and 70 companies that have worked with us. So great success for European cooperation overall, and also with the support of the member states of the agency, which I would like to thank. And last but not least, a big thank you also to the ESA teams who worked hard on this program for the last 14 years.
Congratulations to the teams, indeed. Thank you, Simonetta. Hervé Deret, you lead the teams in charge of designing and manufacturing these satellites of tonight. What does it represent to you and your teams?
It's a very important moment for us, for all of us. And by the way, thank you to Ariane Espace for safely delivering this satellite
Thanks
tonight.
To the teams, yeah.
Beautiful launch. Congrats to Stéphane and to all the teams that have been involved. So this is a defining moment for us. MTG-I1 is the first one of this new third generation satellite. It's a very complex program. As a matter of fact, it has not been a piece of cake, as we all know. In fact, we are really talking about cutting-edge technology. It turns out that our teams have been involved and very committed to this program with passion and a very strong commitment. I'd like to thank ESA and EUMETSAT for the team spirit and for putting your trust in our teams. This is extremely important for us, and I think it's this team spirit that has, let's say, provoked, or that is at the origin of this common success. So thank you very much for all of that. Now, in a few minutes, we will have a communication with the satellite from our Fucino center, and then from that time, our operation center in Italy, in Fucino, will operate the satellite up to its let's say, final orbit, and we will start a long commission.
Ladies and gentlemen, we are back live from ESA's technical heart here in the Netherlands, and we are about an hour after launch, where we saw the liftoff of the Ariane 5 rocket from Europe's Spaceport in French Guiana with MTG on board, and we also saw on the Ariane Space transmission the separation of MTG. Now we are waiting for confirmation of the solar array deployment, which we expect to hear from the Fucino Space Center in Italy.
And we are joined here on stage by Sean Burns, Director of Operations and Services to Users at EUMETSAT, and ESA's MTG Satellite Systems and Operations Manager, Peter van der Brembuske. What did it feel like to see your baby rocket into space, Peter?
Oh, that was fantastic to see it go up, yeah. But now the stress level is increasing.
How was it for you, Sean?
Yeah, I mean, it was absolutely fantastic to see something blue sky,
to see the separation, and then even seeing the fairing come off was incredible. I've never seen that before, and I've seen a few rocket launches before. So, as Peter said, I'm a bit nervous now, but it's always the case.
I mean, yeah, it was truly a beautiful launch to see. And I mean, also seeing here in the audience and seeing with everyone up on stage how many different people were involved. How was that also to hear from friends and family for you?
It was very nice, yes. Everybody is very enthusiastic and they're all very happy. That's nice to see. It's not just us who worked on the project that is excited. It's much more people. That's very nice.
Yeah, absolutely. It brings home to you just how many people are involved from all, not just the companies, the organizations, but all the users who are invested in the outcome of what we're trying to do here. So it's been, yeah, it really brings it home to you.
That's amazing, absolutely amazing. Now, does it feel a bit like it's your baby that you're sort of sending up into the sky? Like it's like sending your kid off to college and, oh, what's going to happen now?
Yes.
It's all out of your hands now.
Yeah, just wonder if they're going to come back home and ask for more money.
Oh, gosh. No, the problem is they'll give you more money and you have to make more satellites.
Yeah, exactly.
Good. Well, we're still just waiting to hear from Fushino. I have the production in my ear, so as soon as I get that call, I will know that we have Fushino on the line. And so how about the launch and early operations phase? What's happening right now?
You can see it on the screen here. We had first the solar array deployment, and now we see that we have to go to geostationary orbit, because we are launched in an orbit where the perigee, that's the part closest to the Earth, is at 250 kilometers above the Earth, very close. But the apogee, the further part, is already at the right altitude, 36,000 kilometers. And then in 4 different burns of the main engine, we have to go to a circle of 36,000 kilometers above the Earth. And that is coming that will happen in the coming days. So tomorrow they will, if the solar arrays deploy and the satellite is in good health, then they will determine the orbit of the satellite to know exactly which burn to give when they are there at the blue dot. And then the day after, we'll do the burn. First, we will practice everything without the burn, and then we'll do the burn. And once we are in the right orbit, at geostationary, then the antennas will deploy, as you can see here. And then we continue the testing of the satellite. We test that the antennas are working properly. And when they work properly, we open the cover of the FCI. Because there's no contamination there.
Which again is not in this formation that we see on stage, but that
exactly.
is how
that's
it's
how it should
be.
That's a success if it's like that, yes.
Okay, great. And when does that open? When does that operation happen?
That will probably be after Christmas.
Okay.
Yeah.
Okay, so we have some time there.
Yes.
We have some time, okay. So we're still just waiting for confirmation from the Fushino Space Center. What could be happening there right now? What do they see on screen?
They'll be waiting for the telemetry, so they've already got telemetry and they can see what's happening. They've been looking at the telemetry, seeing all the parameters, and really just waiting for that sequence to happen, which is all automatic. So hopefully we should hear very, very soon.
Okay, now tell me a bit more about these solar arrays. I mean, of course, we need them to get power, but how big are they? I think we can also use the model behind us. What are we talking about size-wise and power-wise coming from the solar arrays?
I don't know the exact number by heart, to be honest. But I know it's not a lot. For example, the battery is really only 5% of an electric car. So it is really... Somebody mentioned it in the audience.
Yeah. Ask your team in the audience to help out.
It's a few kilowatts, but I don't know the exact number.
Great, great. And again, it's very important that we have this deployment. Otherwise,
yes,
no solar arrays,
it's very important.
No power, and then no mission. That would be a tragedy.
Part is needed for the platform, for the actuators, the sensors, and so on, to comment all of that. And part of it will be later for the instruments that need a lot of power, because we need to cool the instruments a lot. But even before that, we already need to have the instruments at the right temperature.
I'm sorry to interrupt you. We have news from Fushino. Let's hear.
Yes, okay.
Now the satellite will start pointing the sun, and in a few minutes at 21:55, we will uplink the first telecommand from the Yataraga ground station, and we'll start our work.
Oh, well, thank you so much, Gianni. Thank you for that latest information. Everyone here is elated. It's fantastic news. Gareth, a comment on that?
It's fantastic news. Really, getting the solar arrays deployed is one of the major milestones in ensuring the satellite survival.
So there we go.
Thank you so much.
That truly is exciting news. So congratulations to you. Congratulations to all the teams involved. So many people in this room, but also at Europe Spaceport in Kourou. Thank you for joining us. Now, Peter has stepped off stage, and in his place, I've asked Tony Torker-Nielsen to join us for some final words. Please, Tony, go ahead.
Thank you very much. So, the solar panels is deployed. I asked Peter earlier today, but Peter, they are so small. Is it really important that they deploy? Can we not? And he convinced me that it's very important. So now we have a mission in orbit, and it's alive and breathing like a baby, newborn. So I think we can declare MTG a success.
Can I also invite Sean for some final words? How do you feel?
Yeah, no, I'm absolutely elated. I can actually start to relax. I can feel my body relaxing now, and I may even have a drink now. So, yeah, I mean, I would just like to say thank you. I mean, on behalf of all of EUMETSAT, just like to thank ESA. I'd like to thank OHB, Thales, Leonardo, and anybody else who I forget. But everybody here, I'd like to thank all the Chiara and Kelsey and all the guys backstage. Absolutely fabulous job, very professional. I think it's just now we can actually start the real work of commissioning the satellite and getting that data to users so we can use it to do all those things we promised. So just to say thank you, and a final word to Tony.
Thank you, Sean. Yes, you said now the final work can start, but also now indeed the party can start, because now we can start to celebrate MTG alive in orbit. So have a good party.
Well, we are now approaching the end of our launch event here at ESTEC, and if you would like to stay up to date with the progress of MTG, you can follow ESA's social media channels, or you can follow our website. If you're from the media and you are here with us in ESTEC, you can join us, you can speak with one of our PR representatives, and we can get you in touch with one of our experts.
We'd also like to thank Ruud for his lovely work on the whiteboard, as well as thank you to our lovely audience as well, who are here in the room, but also at our external sites. Thank you for everyone watching the program, and thanks to our followers on ESA Web TV and the live stream who have helped to make this event happen. I'm Chiara Monter.
And I'm Kelsey Brennan-Wessels. It has been an absolute pleasure to host this event here at ESA's Space Technology Center in the Netherlands.
We hope that you all have a safe journey home, and we hope that you will be able to join us next time.
Thank you once again. Goodbye and good night.
Bye.